nature of silicon, and the very big of this chicken
Hello. Check. Hello. 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 Check. Hello.
Good morning. Be seated. Please be seated. We just want to announce that the President of India has sent the greetings to Professor C.N.R. Rao on his 91st birthday. The Deputy Secretary Protocol, Mr. Abhijin, is handing over the bouquet and the greetings to Professor C.N.R. Rao. Please join your hands. Okay. Abhijin, open ಮಾಡ್ಕೊಡಿ. Mr. Abhijin, Deputy Secretary from Government of Karnataka, representing the President's office, has just handed over. The greeting from the President of India reads like this: Dear Professor Rao, please accept my warm greetings and good wishes on your birthday on 30th/6/2025. May God bless you with good health, happiness, and a long life in the service of the nation. Draupadi Murmu, President of India. Thank you.
We have another 5 minutes. Okay. Meanwhile, our one of flagship program, we have flagship program, different places of India. And this is one of our flagship program, that is School Chandan Lakshmeshwar. They are celebrating Professor Rao's birthday. And I request School Chandan to go ahead. You have 3 minutes. Yeah. Thank you.
Madam, we'll start.
Good morning. Ellarigu namaskaralu. Namaskar to everyone. It is indeed a great privilege and special honor for me to begin today's very special event on behalf of the Education Technology Unit of JNCASR and the C.N.R. Rao Education Foundation. You all know we are gathered here on a very special occasion to celebrate the birthday of our beloved Professor C.N.R. Rao, who is also the Bharat Ratna, who has been conferred with a very special civilian honor of this country. I also welcome all the other distinguished guests here. Our President, Professor Umesh V. Wagmare. Our previous presidents are also here. Thank you, Professor G.U. Kulkarni, Professor V. Krishnan, also Professor Ashutosh Sharma, the former Secretary of the Department of Science and Technology. I also welcome all the young students who have come here from far. I know within and maybe surrounding Bangalore, but in Bangalore, everything is pretty far. Today, it's very special because on Professor Rao's birthday, he has chosen to honor teachers. He could have done anything. I think it's especially nice that he has chosen to celebrate his birthday with people who share knowledge and learning. This is a tradition over many, many years here at JNCASR. And to begin, I welcome Mr. A.N. Jayachandra, our former administrative officer, to tell us about the foundation and its tradition.
Good morning to everyone. Respected Bharat Ratna Professor C.N.R. Rao, President JNCASR Professor Umesh Wagmare, Professor Ashutosh Sharma, our guest of the day, Professor G.U. Kulkarni, immediate past President of JNCASR, the Administrator of the C.N.R. Rao Education Foundation, Dr. Indumati Rao, Professor K.N. Ganesh, JNCASR Council Member, Suchitra, Suguna, Sanjay, members of Professor Rao's family, distinguished members of the Teachers Award Selection Committee, Professor Gururaj Karjagi, Professor Ramaswamy, he is not here today, Dr. Srikanteshwar Swami, he is also not there, Dr. B.R. Guruprasad, and Sri Dwarkanath sir, former presidents of JNCASR, Professor V. Krishnan, Professor V. Nagaraja, teacher awardees, deans of JNCASR, Professor Shiba, chair of the ETU, chairs of the units of JNCASR, distinguished faculty members, administrative officer of JNCASR, Mr. Jaideep Deb, and other officers of JNCASR, invitees, and especially the students and the teachers who have come all the way from different schools to our center today. In the beginning, on behalf of all of you, let me pay my respectful wishes to Bharat Ratna Professor C.N.R. Rao for having reached this glorious 91 years. Please join hands in. Every year, June 30 is a special day to this center for all of us to celebrate Sir's birthday, honoring science teachers in the presence of scientists, teachers, and students. This creates a great legacy in future also. Sir, we feel honored and privileged to have your contact, association, guidance, love and affection from you and Mrs. Rao both. And on behalf of the C.N.R. Rao Education Foundation, it is my privilege to congratulate the 4 awardees of 2024 Science Teachers Prize, Mr. Nagaraja CM from Bangalore Rural, Mr. Lingaraj Virappa Ramapur from Hubli, Dr. Rajesh Kumar Pandey from Bhadoni, Uttar Pradesh, and Madam Chitra from Hisar, Haryana state. We are grateful to the members of our jury, the selection committee, for having helped us in the selection process all these years. This is the 19th prize. I'm sorry, this is the 20th prize. Ladies and gentlemen, I need to speak to you about the C.N.R. of Education Foundation. And before that, I would like to remember one verse of the Mankutimana Kagga, a great poet, Dr. D.V. Gundappa, has written. In Kannada, it reads, Hullagu bettadadi manege malligeyagu ಕಲ್ಲಾಗು ಕಷ್ಟಗಳ ಮಳೆ ವಿಧಿಸುರಿಯೇ ಬೆಲ್ಲ ಸಕ್ಕರೆಯಾಗು ದೀನ ದುರ್ಬಲರಿಂಗೆ ಎಲ್ಲರೊಳಗೊಂದಾಗು ಮಂಕುತಿಮ್ಮ. Ladies and gentlemen, Professor Rao lived whole of his life like this. True to this verse, though he is a mountain of knowledge and fame, he wished to be like hay. For whom he is mallige, jasmine. He faced many difficulties in life to reach the pinnacle of knowledge and fame, and when difficulties poured on him, he faced it like a hard rock. With all these, he became as sweet as jaggery or sugar for the needy and the underprivileged. And despite all these achievements and recognitions, he became one among us, and that is why he is here. Thank you. So we all live in our life, but only a few try to find purpose in life, going through a personal journey of self-discovery, often involving exploring passions, values, and strengths to create a fulfilling and meaningful existence, identifying what truly matters, aligning their actions with those values. Generally, this happens when every one of us are aged. Professor Rao spent his entire life in exploration, self-discovery, pursuing his benevolent passions. I must mention, very interestingly, that Dr. Indumati Rao joined hands in each of his endeavors. Some of us distinctly remember that once in a remote village of Karnataka, a little girl asked Madam Rao, "What is your contribution to Professor Rao getting Bharat Ratna?" Without blink and an eye, Mrs. Rao replied that she allowed Professor C.N.R. Rao to pursue his passion without bothering him with mundane issues at home. So it is a successful story of chemistry also for both of them and our country. And very interestingly, both of them decided not to buy gold, not to have expensive cars, not to live in luxurious bungalows, not to follow extravaganzas, but live a simple life, be with the people and help the needy. And that is why this foundation is in existence. They decided that they will have to promote education, particularly science education, and with that the personal savings of their family. And in this regard, throughout their life, they were doing philanthropy till the year 2024. But when Professor C.N.R. Rao received a rare international recognition with a substantial money, it is called the Dan David Prize. It's also called the Israeli Nobel Prize in the year 2024. They discussed in length what needs to be done to the society, and they decided that they will give a proper structure to all the philanthropy they have been doing till then, and thus the C.N.R. Rao Education Foundation was established in the year 2005, using the family savings with the vision and objective of promoting education, particularly science education, and recognize scholarship. Since 2005, the foundation's core activities include conducting science outreach programs throughout India, with a particular focus on rural areas to inspire young minds. Several programs were held in different places of Karnataka, Kerala, Tamil Nadu, Uttarakhand, Rajasthan, Gujarat, and debut so far. Mr. Vinayak, you may confirm that. The next month we are going to UP, Ayodhya, and also Nagaland. Am I right? Yeah. So this many states the foundation has covered, through the outreach programs. And the C.N.R. Foundation also has facilitated and supported science outreach programs held in the Hall of Science, in this very Hall of Science, which has been donated by Professor C.N.R. Rao frequently, not less than once in a month, in collaboration with the Education Technology Unit of JNCASR. And the other program is in order to recognize the science teachers of the country and to encourage the science teaching and promote the cause of understanding the vital role of science educators in the development of society. The C.N.R. Foundation has instituted National Award annually in the year 2005. This award is for outstanding science teachers at the school and PUC levels, and that is why all these teachers, have been given the award for the 21st year. Each award ceremony also features a popular science lecture aimed at students and teachers, and Dr. B.R. Guruprasad will give a talk today. And in the evening, very eminent musicians are invited, and this time Dr. Praveen Gorkindi, he will play flute in the evening at 4 o'clock. The foundation also has announced annual national award for researchers in the frontier areas of chemistry to honor the best researchers in the country. And every year, the theme of this award is different. And this year, the focus was on supramolecular chemistry. The prizes will be announced maybe in a month's time. And in order to encourage the talented young students to pursue science at undergraduate and postgraduate levels, the foundation has instituted various prizes and awards in institutions and universities nationwide. The foundation has supported prizes in IITs, ISERs, universities, institutions all over the country. And the foundation also has built 2 halls of sciences, one in Uttarakhand and the other one in a remote village in Karnataka. And these science centers, they are called science centers or the halls of science. They conduct science outreach programs on a very regular basis. In addition to this, in the year 2020, a unique scholarship program was instituted in a rural village in Karnataka. Another initiative of the foundation is supporting a science foundation called the Sagar Science Forum, situated in a very small town of Karnataka, helping them to conduct workshops and programs for science teachers and students, particularly to promote science education among the rural girls. The foundation also runs student mentoring program aimed at fostering self-study habits, self-reliance among disadvantaged students, offering them opportunities to experience research in premier institutions. Various initiatives are supported from time to time for popularizing science by the foundation, in addition to all these things. And just to name a couple of them, one Tara Mandala in Karnataka and the other one is in Chikbalapur. JNCSR has been steadfast supporter of the foundation in organizing the outreach programs and other programs of the C.N.R. Foundation. And the foundation is ever grateful to the authorities of JNCSR, faculty members, staff of JNCSR for assisting in numerous initiatives. And all the presidents of JNCSR, Professor V. Krishnan, Professor V. Nagaraja, late Professor M.R.S. Rao, Professor Jeev Kulkarni, and Professor Umesh Wagmare have been rendering a great advice and help, throughout the journey of the foundation. And as I informed to you, each year the teacher award ceremony concludes with a musical fest. And today I request you to join us in Dr. Praveen Gorkindi playing the flute. Thank you so much. And it is my great pleasure to welcome Dr. Shiba, Dr. Vinayak, and others to arrange for a cake for Professor Rao's birthday. Thank you so much.
cannot come.
I will move to the next one. Sir, I will move to the next one. I'm sure we will enjoy the cake a little later, so we will continue with the proceedings of today, for which I would like to invite our President, Professor Umesh V. Wagmare, to please come up on the dais. Now, the awards will be presented to the awardees, and I will be reading the felicitation for each of the awardees. Firstly, Mr. Nagaraj CM. Shri Nagaraja CM is an assistant master at the Government High School, Dodda Banahalli, Bangalore South. He has 19 years of experience in teaching chemistry and biology. He has consistently demonstrated excellence in pedagogy, innovation in science education, and a deep commitment to community and school development. He has made significant contributions to science education, including developing e-content for the Diksha portal, serving as a content reviewer for the Diksha portal, contributing to district-level workbook and model questions, question bank preparation as a resource person. He has set up and developed the school laboratory. He has served as a resource person in writing lab manuals for DSERT and conducted various science awareness programs in school. He has been recognized with numerous other accolades, including the Best Teacher National Award 2021, Best Teacher Bangalore South District 2020, Kannada Seva Ratna Award 2020, Outstanding Teacher Award by BET College. He has also received recognition from Synopsys India Private Limited as Best Guiding Teacher in Disha 2007 for contributions to science education and participation in multiple science workshops and related initiatives. The C.N.R. Rao Education Foundation takes great pleasure in honoring Shri Nagaraja CM for his dedicated service and exceptional contributions to the cause of science education. Congratulations, Shri Nagaraja. Our next awardee, Dr. Lingaraj Veerappa Ramapur. Dr. Ramapur is an assistant master at Government High School, Kiresur, Hubli, with 25 years of service. He has contributed extensively to science education through his innovative teaching methods and prolific writing, including 30+ science books and over 500 articles in Kannada. He has motivated students to participate in science events, established space lab in the school with the help of an NGO, and conducted space-related activities for students at Government High School, Keresur, 2023-24. He conducted sessions for students, youth, and public to create awareness. Dr. Ramapur has received numerous awards and recognitions, notably Shikshana Prabha Award 2024 by Children's Academy, the Karnataka Government Academy Award for his book Enu AK, the Special Teacher Award by the Government of Karnataka, along with Namma Mestru recognition by Kannada Dailies and the Taffet Winner Award from the Times Group. The Karnataka Government Academy Award 2017 for the book Vignanada Aledata, the Nation Builder Award 2016 by Rotary India Literacy Mission, and the State Book Award 2014 by the C.B. Hunbal Librarian Foundation. The C.N.R. Rao Education Foundation takes great pleasure in honoring Dr. Ringaraj Veerappa Ramapur for his dedicated work for the cause of science education. Congratulations, Dr. Ramapur. Our third awardee is Dr. Rajesh Kumar Pandey. Dr. Rajesh Kumar Pandey is an assistant teacher in life science at VNGIC Gyanpur Bhadohi, Gyanpur, Uttar Pradesh. He has served for more than 2 decades, 26 years as a teacher. He made significant contributions to science education, particularly through demonstrating and explaining scientific principles to dispel social myths and false beliefs. Conducting science programs on topics such as safe drinking water, plastic pollution, agriculture, waste reuse and management, health, hygiene, sanitation, and environmental cleanliness, especially in rural areas, organizing science popularization programs in schools and colleges, and leading Vigyan rallies and participating in district level children's science festival and coordinating visits to industrial and scientific institutions for students in science and technology and Vigyan Melas. Dr. Pandey has received the USAID and India Support for Teacher Education Program Fellowship for Teacher Educators in 2014 and has served as a visiting faculty under the InSTEP program at Arizona State University and has also received national awards for innovative practices and experiments in education for school and teacher education. The C.N.R. Rao Education Foundation takes great pleasure in honoring Dr. Rajesh Kumar Pandey for his dedicated service and exceptional contributions for the cause of science education. Congratulations, Dr. Pandey. Our third awardee, she is a special awardee from the C.N.R. Rao Science Foundation, and this is Mrs. Chitra Singh. Mrs. Chitra Singh is a retired assistant teacher of biological science at Government High School, Chikanwas, Hisar, Haryana, where she served for more than 2 decades. She has made significant contributions to science education, particularly through demonstrating and explaining scientific principles of the solar eclipse using a self-prepared model and securing the 2nd position in the national TLM competition organized by Agastya International Foundation. She has served as a science fair evaluator at B.Ed College in Hisar. She has been working as a science educator for school students, demonstrating popular experiments in science and astronomy using self-made scientific kits funded personally. She has been writing popular science articles for VIPNET Curiosity magazine, published by Guruprasad, Department of Science and Technology, Government of India. Mrs. Chitra Singh received the National Best Science Teacher Award at Burhanpur from the Raman Science and Technology Foundation and the National Council of Teacher Scientists. She has also contributed significantly to science outreach through serving as a resource person for astronomy at Scientific Temperament Workshop in Gurugram, working with Agastya International Foundation in Bengaluru as an evaluator for student projects, participating in a small-scale chemistry workshop at JNCASR recently. The C.N.R. Rao Education Foundation takes great pleasure in honoring Mrs. Chitra Singh for her dedicated service and exceptional contributions for the cause of science education. Congratulations, Mrs. Chitra Singh. Now is the time to look or listen to the responses by each of our awardees. First, I call upon Mr. Nagaraj CM.
ವೇದಿಕೆ ಮೇಲೆ ಉಪಸ್ಥಿತರಿರುವಂತಹ ಭಾರತ ರತ್ನ ಅವಾರ್ಡಿ ಭಾರತ ರತ್ನ C.N.R ರಾವ್ ಅವರೇ, ಧರ್ಮಪತ್ನಿಯವರೇ ಹಾಗೂ ಎಲ್ಲ ಸಹೃದಯರೇ, ವಿದ್ಯಾರ್ಥಿಗಳೇ ಹಾಗೂ ತಮ್ಮ ಜೀವನವನ್ನ ಸಮಾಜದ ಒಳಿಗಾಗಿ ಮುಡುಪಿಟ್ಟು ಸದಾ ಸಂಶೋಧನೆಯಲ್ಲಿ ತೊಡಗಿರುವಂತಹ ಹಲವು ವಿಜ್ಞಾನಿಗಳೇ, ಸಂಶೋಧನಾರ್ಥಿಗಳೇ ಹಾಗೂ ಈ ದಿನ ಆಗಮಿಸಿರುವಂತಹ ಎಲ್ಲ ಆಸಕ್ತರೇ, ಮೊಟ್ಟ ಮೊದಲಿಗೆ ನಾನು ನಮ್ಮೆಲ್ಲ ಕನ್ನಡಿಗರ ಪರವಾಗಿ C.N.R ರಾವ್ ಅವರಿಗೆ ಹುಟ್ಟುಹಬ್ಬದ ಶುಭಾಶಯಗಳನ್ನ ವ್ಯಕ್ತವಾಗಿ ತಿಳಿಸ್ತಾ, ಈ ದಿನ ನಾನು ಒಂದು ಮಹತ್ವದ ದಿನ, ನನ್ನ ಜೀವನದಲ್ಲಿ ಮಹತ್ವದ ದಿನ ಅಂತ ನಾನಾದ್ರೂ ಭಾವಿಸ್ತೇನೆ. ಪ್ರತಿಯೊಬ್ಬ ಶಿಕ್ಷಕರಿಗೂ ಒಂದು ಕನಸಿರ್ತದೆ, ನಾನು ನನ್ನ ವಿದ್ಯಾರ್ಥಿಗಳಲ್ಲಿ ವಿಶೇಷವಾಗಿ ನಿಲ್ಲಬೇಕು, ವಿದ್ಯಾರ್ಥಿಗಳನ್ನ ನಾನು ನನಗೆ ನನ್ನ ಶಿಕ್ಷಕರು ಹೇಗೆ ಮಾದರಿಯಾಗಿ ನಾನು ತಗೊಂಡಿದ್ನೋ ಅದೇ ರೀತಿ ನಾನು ಕೂಡ ಮಾದರಿ ಆಗಬೇಕು ಅಂತೇಳಿ ಬಹಳಷ್ಟು ಶಿಕ್ಷಕರಿಗೆ ಆ ಒಂದು ಕನಸಿರ್ತದೆ. ಆ ನಿಟ್ಟಿನಲ್ಲಿ ಕಾರ್ಯವನ್ನು ಕೂಡ ಮಾಡ್ತಾ ಇರ್ತಾರೆ. ಇವತ್ತು ನನಗೆ C.N.R ಅವರ ಒಂದು ಅವಾರ್ಡ್ ಅನ್ನು ಬಂದಿರ್ಬೋದು, ಆದರೆ ನನ್ನಂತೆಯೇ ಬಹಳಷ್ಟು ಜನ ಶಿಕ್ಷಕರು ಇವತ್ತಿಗೂ ಕೂಡ ಶಾಲೆಗಳಲ್ಲಿ ಕೆಲಸ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಅವ್ರು ಯಾರು ಕೂಡ ಅರ್ಜಿಯನ್ನು ಸಲ್ಲಿಸಿಲ್ಲ, ಆದರೆ ಅದ್ರಲ್ಲಿ ನಾನು ಅರ್ಜಿ ಸಲ್ಲಿಸಿದ್ರಿಂದ ಈ ಒಂದು ಪ್ರಶಸ್ತಿಯನ್ನು ನಾನು ಪಡ್ಕೊಂಡಿದ್ದೀನಿ. ಯಾವುದೇ ಅರ್ಜಿ ಸಲ್ಲಿಸದೆ ಕೆಲಸ ಮಾಡ್ತಿರುವಂತ ಎಲ್ಲ ಶಿಕ್ಷಕರಿಗೂ ಕೂಡ ನಾನು ಈ ಒಂದು ಅವಾರ್ಡನ್ನು ನಾನು ಅವರಿಗೆ ಸಮರ್ಪಣೆಯನ್ನ ಮಾಡ್ತಾ, ಯಾಕೆ ಪ್ರಶಸ್ತಿ ಮಹತ್ವದಾಗುತ್ತೆ ಅಂತೇಳಿ ನಾನು ಹೇಳಲಿಕ್ಕೆ ಬಯಸ್ತೇನೆ. ಶಿಕ್ಷಕರಾದವರು ಕೆಲಸವನ್ನು ನಾವೇನು ಮಾಡ್ತಾ ಇರಬೇಕಾದ್ರೆ ನಮಗೆ ಒಂದಿಷ್ಟು ಮೋಟಿವೇಶನ್ಗಳು ಖಂಡಿತವಾಗಿಯೂ ಬೇಕಾಗ್ತದೆ. ಆ ಮೋಟಿವೇಶನ್ಗಳು ಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ನನ್ನ ಸ್ನೇಹಿತರುಗಳಿರ್ಬೋದು, ನನ್ನ ಅಧಿಕಾರಿಗಳಿರ್ಬೋದು, ಅವರೆಲ್ಲರೂ ಕೂಡ ನಮ್ಮನ್ನ ಕಾರ್ಯಗಳನ್ನ ನೋಡಿ ಪ್ರಶಂಸುತ್ತಾ ಇರ್ತಾರೆ. ಅದರ ಬಗ್ಗೆ ಅವರು ಒಳ್ಳೆಯ ಮಾತುಗಳನ್ನ ಆಡ್ತಾ ಇರ್ತಾರೆ. ಸೊ ಇವುಗಳು ನಮ್ಮನ್ನ ಕೆಲಸವನ್ನ ಮಾಡಲಿಕ್ಕೆ ಒಂದು ಒಳ್ಳೆಯ ಪ್ರೇರೇಪಣೆಯನ್ನು ಕೂಡ ಖಂಡಿತವಾಗಿ ಕೊಡ್ತದೆ. ಅದ್ರ ಜೊತೆಗೆ ಈ ಒಂದು ಅವಾರ್ಡ್ಗಳೇನಿದಾವಲ್ಲ, ಇವು ಇನ್ನೆಷ್ಟು ಹೆಚ್ಚು ಪ್ರೇರಣೆಯನ್ನ ನಮಗೆ ಕೊಡ್ತದೆ. ನನಗೆ 2021ರಲ್ಲಿ ರಾಷ್ಟ್ರ ಪ್ರಶಸ್ತಿಯನ್ನು ಬಂದಂಥ ಸಂದರ್ಭದಲ್ಲಿ ಕೋವಿಡ್ ಇರೋ ಕಾರಣ ಅವತ್ತು ರಾಷ್ಟ್ರಪತಿಗಳನ್ನ ನೇರವಾಗಿ ಮುಖಾಮುಖಿಯಾಗಿ ಆ ಒಂದು ಪ್ರಶಸ್ತಿಯನ್ನ ಪಡೀಲಿಕ್ಕಾಗಲಿಲ್ಲ. ವರ್ಚುವಲ್ ಅಲ್ಲಿ ಅವತ್ತು ನಾನು ಪಡ್ಕೊಂಡೆ. ಇವತ್ತು ಅಂಥದ್ದೇ ಒಂದು ಸಂದರ್ಭ, ಭಾರತ ರತ್ನ C.N.R ಅವರ ಸಮ್ಮುಖದಲ್ಲಿ ಅವರ ಒಂದು ಫೌಂಡೇಶನ್ ನಲ್ಲಿ ಪ್ರಶಸ್ತಿಯನ್ನು ಪಡಿಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಇದು ಪ್ರತಿಯೊಬ್ಬ ವಿಜ್ಞಾನ ಶಿಕ್ಷಕನ ಒಂದು ಕನಸಾಗಿರ್ತದೆ. ನಾನು ಕೂಡ ಅಂತ ಒಂದು ಪ್ರಶಸ್ತಿಯನ್ನು ಪಡಿಬೇಕು ಅಂತೇಳಿ. ಒಂದ್ಸಾರಿ ಈ ತರದ ಒಂದು ರೆಕಗ್ನೇಷನ್ ಬಂತು ಅಂತ ಹೇಳಿದ್ರೆ ನಮ್ಮ ಜವಾಬ್ದಾರಿ ಖಂಡಿತವಾಗಿಯೂ ಕೂಡ ಹೆಚ್ಚಾಗುತ್ತೆ. ನಮ್ಮ ಕೆಲಸ ಮತ್ತು ಮಾಡುವಂತಹ ಕಾರ್ಯದಲ್ಲಿ ನಾವು ಹೆಚ್ಚು ಹೆಚ್ಚು ಪ್ರಾವೀಣ್ಯತೆಯನ್ನು ಪಡ್ಕೊಳ್ಬೇಕಾಗತ್ತೆ. ಜೊತೆಗೆ ನಮ್ಮ ಜೀವನದಲ್ಲಿ ಶಾಲೆಯ ಹೊರಗೆ ಮತ್ತು ಒಳಗೆ ನಾವು ಹೇಗೆ ನಡ್ಕೊಳ್ಬೇಕು ಅನ್ನುವಂಥದ್ದು ಸದಾ ನಮ್ಮನ್ನು ಎಚ್ಚರಿಸ್ತಾ ಇರ್ತದೆ. ಯಾಕಂದ್ರೆ ನಾವು ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಮತ್ತು ಸಮಾಜಕ್ಕೆ ಮಾದರಿಯಾಗಿರ್ಬೇಕಾದಂತಹ ಶಿಕ್ಷಕರಾಗಿರೋದ್ರಿಂದ ಇಂತಹ ಪ್ರಶಸ್ತಿಗಳು ಆ ನಿಟ್ಟಿನಲ್ಲಿ ಬಹಳಷ್ಟು ಮಹತ್ವವನ್ನು ಪಡ್ಕೊಳ್ತವೆ ಅಂತೇಳಿ ಭಾವಿಸ್ತೀನಿ. ಅಂತಹ ಒಂದು ಪ್ರಶಸ್ತಿಗೆ ಭಾಜನರಾಗಿರುವಂಥ ನಾನು ಧನ್ಯ ಅಂತೇಳಿ ಭಾವಿಸ್ತಾ, ಈ ಒಂದು ನನ್ನ ಕಾರ್ಯಕ್ಕೆ ಸಹಕಾರ ಕೊಟ್ಟಂತಹ ಎಲ್ಲ ನನ್ನ ಪ್ರೋತ್ಸಾಹಿಸಿದಂಥ ನನ್ನ ಕುಟುಂಬದವರಿಗೆ, ಹಾಗೆ ನನ್ನ ಇಲಾಖೆಯ ಎಲ್ಲ ಅಧಿಕಾರಿಗಳಿಗೆ, ಹಾಗೂ ಈ ಒಂದು ಅವಕಾಶವನ್ನು ಕೊಟ್ಟಂತ JCSRನ ಎಲ್ರಿಗೂ ಕೂಡ ಸರ್ವರಿಗೂ ಕೂಡ ನಾನು ನನ್ನ ಧನ್ಯವಾದಗಳನ್ನ, ಕೃತಜ್ಞತೆಗಳನ್ನ ಸಲ್ಲಿಸ್ತೇನೆ. ಜೈ ಹಿಂದ್, ಜೈ ಕರ್ನಾಟಕ.
Thank you, Shri Nagaraj. Now I call upon Dr. Lingaraj Ramapur to please give us his response.
ವೇದಿಕೆಯ ಮುಂಭಾಗದಲ್ಲಿ ಆಸೀನರಾದಂತಹ ನನ್ನ ಮಾರ್ಗದರ್ಶಕರು ಮತ್ತು ಪ್ರೇರಣೆಯಾದಂತಹ ಭಾರತ ರತ್ನ ಡಾಕ್ಟರ್ C.N.R ರಾವ್ ಸರ್ ಅವರೇ, ಹಾಗೂ ಎಲ್ಲ ಹಿರಿಯ ವಿಜ್ಞಾನಿಗಳೇ ಹಾಗೂ ಶಿಕ್ಷಕರೊಂದವೇ ಮತ್ತು ಮುದ್ದು ಮಕ್ಕಳೇ, ನಾನು 27 ವರ್ಷ ಸರ್ವಿಸ್ ಅಲ್ಲಿ ಇದೊಂದು ಮರೆಯಲಾಗದಂತಹ ಒಂದು ಘಟನೆ ಅಂತ ನಾನು ಅನ್ಕೊಂಡಿದ್ದೇನೆ. ಈ ಸಂದರ್ಭದೊಳಗೆ ಈ ಒಂದು ಪ್ರಶಸ್ತಿ ನನಗೆ ಕೆಲಸ ಮಾಡಲಿಕ್ಕೆ ಇನ್ನಷ್ಟು ಉತ್ಸಾಹವನ್ನ ಇಮ್ಮಡಿಗೊಳಿಸಿದೆ. ಈ ಹಿನ್ನೆಲೆಯೊಳಗೆ ನಾನು ವಿಜ್ಞಾನವನ್ನ ಒಂದು ವಿಷಯವಾಗಿ ಅಂತ ಅಲ್ಲ, ಅದೊಂದು ಒಂದು ಪ್ರೊಸೆಸ್, ಜೀವನವನ್ನ ಸುಧಾರಿಸ್ತಕ್ಕಂತಹ ಒಂದು ಯಜ್ಞ ಅಂತ ಅನ್ಕೊಂಡು ವಿದ್ಯಾರ್ಥಿಗಳಲ್ಲಿ ವೈಜ್ಞಾನಿಕ ಮನೋಭಾವನೆಯನ್ನ ಬಿತ್ತಕ್ಕಂತಹ ಕೆಲಸವನ್ನ ನಿರಂತರವಾಗಿ ಮಾಡ್ತಾ ಬಂದೆ. ಬಹುಶಃ ಅದೇ ನನ್ನ ಇವತ್ತು ಈ ಒಂದು ವೇದಿಕೆಗೆ ತಂದು ನಿಲ್ಲಿಸಿದೆ ಅಂತ ನಾನು ಭಾವಿಸಿದ್ದೇನೆ. ನನ್ನ ವೃತ್ತಿಯುದ್ದಕ್ಕೂ ಕೂಡ ಮಾಡಿದಂಥ ಹಲವಾರು ಕೆಲಸಗಳು, ನಾವೀನ್ಯಯುತ ಪ್ರಯೋಗಗಳು ಇವತ್ತು ನನ್ನ ವಿದ್ಯಾರ್ಥಿಗಳನ್ನ ಶ್ರೇಷ್ಠ ಮಟ್ಟಕ್ಕೆ ಏರಿಸಲಿಕ್ಕೆ ಕಾರಣ ಆಗಿದೆ. ಅಜ್ಞ ಮತ್ತು ತಜ್ಞರ ಒಡನಾಟದಿಂದ ವಿಜ್ಞಾನ ಸಂವಹನ ಅನ್ನುವಂತಹ ಒಂದು ಮಾತಿದೆ. ಇದು ವಿಜ್ಞಾನ ಅನ್ನೋದು ಬರೀ ವಿದ್ಯಾರ್ಥಿಗಳಿಗಾಗಿ ಅಷ್ಟೇ ಅಲ್ಲ, ಅದು ಜನಸಾಮಾನ್ಯರಿಗೆ ಮುಟ್ಟಬೇಕು, ರೈತರಿಗೆ ತಲುಪಬೇಕು, ಕಾರ್ಮಿಕರಿಗೆ ತಲುಪಬೇಕು. ಅಂದಾಗ ಮಾತ್ರ ವಿಜ್ಞಾನದ ಸಂಶೋಧನೆಗಳು ಮತ್ತು ಅದರ ಫಲಿತಗಳು ಎಲ್ಲ ಜನಸಾಮಾನ್ಯರನ್ನ ಮುಟ್ಟಬೇಕು ಅನ್ನುವಂಥ ನಿಟ್ಟಿನೊಳಗೆ ಕೆಲಸವನ್ನ ಮಾಡ್ತಾ ಇದ್ದೇನೆ. ಈ ಪ್ರಶಸ್ತಿಗೆ ನನ್ನ ಈ ಪ್ರಶಸ್ತಿಯ ಒಂದು ಗೌರವವನ್ನ ನನ್ನ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಕೊಡ್ಲಿಕ್ಕೆ ನಾನು ಬಯಸ್ತೇನೆ. ಇದು ಇವತ್ತು ಇಲ್ಲೇನಾದ್ರೂ ನನಗೆ ಬಂದಂತ ಬಹುಮಾನ ಇದು ಖಂಡಿತವಾಗ್ಲೂ ನನ್ನ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಸಲ್ತದೆ ಅಂತ ಆಶಿಸ್ತಾ, ನನಗೆ ಸಹಕಾರ ನೀಡಿದಂತ ಇಲಾಖೆ ಮತ್ತು ಎಲ್ಲ ಶಿಕ್ಷಕ ವೃಂದಕ್ಕೂ ಮತ್ತು ಕುಟುಂಬ ವರ್ಗಕ್ಕೂ ವಂದಿಸಿ ನನ್ನ ಮಾತು ಮುಗಿಸ್ತೇನೆ. ನಮಸ್ಕಾರ.
Thank you, Dr. Rampur. Now I invite Dr. Rajesh Kumar Pandey.
नमस्कार. गुरु ब्रह्मा गुरु विष्णु गुरुदेव महेश्वरा गुरु साक्षात परम ब्रह्म तस्मै श्री गुरुवे नमः। इस सभागार में उपस्थित विद्वत जन, हमारे गुरु, और सबसे पहले सर को बहुत बहुत जन्मदिन की बधाई। मेरे लिए सौभाग्य की बात है, एक भारत रत्न मदन मोहन मालवीय की संस्था में मैंने पढ़ा और आज एक भारत रत्न से मैं पुरस्कार पा रहा हूँ। और दूसरी सौभाग्य की बात यह है कि जिस फैकल्टी के सर स्टूडेंट हुआ करते थे 51 या फिर उसके पहले, वहां से मैंने भी पढ़ाई की है, बॉटनी की एमएससी वहीं से मैंने की है। तो मेरे लिए बहुत भावुक क्षण है इस समय कि एक संस्था से पढ़े हुए हम एक गुरु से मैं पुरस्कार ले रहा हूँ, एक लगा हुआ है। और मुझे बहुत अच्छा लगा कि एक साथ इतनी विभूतियों के साथ मैं एक साथ इंटरेक्ट नहीं कर सकता। मैंने आईएससी के लिए, मैंने समर ट्रेनिंग के लिए जब बीएचयू में पढ़ता था तो अप्लाई किया था। अनफॉर्चुनेटली आई डोंट सक्सीड। मैं पिछले 26 साल से विज्ञान शिक्षण से लगा हुआ हूँ और मेरा मानना है कि विज्ञान को केवल किताबों तक न रखा जाए, बल्कि जीवन में उसका उपयोग कैसे हो सकता है। बार बार कहा जा रहा है कि मूल्य शिक्षा का क्षरण हो रहा है और कहने में आता है कि विज्ञान जब से पढ़ाया जा रहा है मानवीय मूल्य समाप्त हो रही है, जबकि हमारे विज्ञान में मानवीय मूल्य हर जगह कूट कूट कर भरा हुआ है। क्लास में बच्चे को सॉल्यूशन पढ़ाते हैं, बिलियन पढ़ाते हैं। वाटर की प्रॉपर्टी कुछ और होती है, सॉलिड की प्रॉपर्टी कुछ और होती है, दोनों अपनी अपनी प्रॉपर्टी छोड़कर शरबत बना देते हैं। तो क्या हम लोग ह्यूमन बीइंग होकर के छोटी छोटी चीजों को छोड़कर के आपस में सामाजिक समरसता का मैसेज नहीं दे सकते? ये जरूरी है क्लास में बताया जाना। जानकारी बहुत ज्यादा है, इंफॉर्मेशन बहुत ज्यादा है, बच्चे हम आपसे कहीं ज्यादा आगे चल रहे हैं। जरूरत है कि क्लास में इस बात पर जोर दिया जाए कि जो बच्चे नहीं जानते उसको बताया जाए, जो हमारी वैल्यू सिस्टम है। और हमारी शिक्षा नीति में भी यही कहा गया था, कोठारी कमीशन में कहा गया कि डेस्टिनी ऑफ इंडिया बीइंग शेप्ड इन क्लासरूम। 1986 की नीति में कहा गया कि कोई भी छात्र अपने शिक्षक से ऊपर नहीं उठ सकता। 2005 में कहा गया कि बाहर के ज्ञान को विद्यालय के ज्ञान के साथ जोड़ा जाना चाहिए। और 2020 में कहा जा रहा है कि हम अर्वाचीन और प्राचीन दोनों को लेकर डिजिटल इंडिया में आगे की तरफ बढ़े। इस परिप्रेक्ष्य में साइंस टीचर का दायित्व ज्यादा बढ़ जाता है। सर, मैं आपको विश्वास दिलाता हूं कि इस क्षेत्र में थोड़ा भी अगर मैं करने में सफल रहूंगा तो अपने को बहुत भाग्यवान मानूंगा। जय हिंद, जय भारत।
Dhanyawad, Dr. Pandey. Now I invite Mrs. Chitra Singh.
Respected Professor C.N.R. Rao, Dr. Indumati Rao, distinguished guests, fellow educators, students, and dear friends. Namaskar and good morning to everyone. It is with immense gratitude and deep humility that I stand before you today to receive the prestigious C.N.R. Rao Outstanding Science Teacher Award. This moment is not just a personal milestone, it is an emotional culmination of a journey that began decades ago, with nothing more than curiosity, chalk duster, and a sincere desire to make science come alive for young students. To be recognized with award that carries the name of one of the greatest scientists of our country and the world has known, Bharat Ratna, Professor C.N.R. Rao, is truly a matter of great pride. What makes this moment even more special is that it comes after my retirement. Almost 3 years ago, it is a reminder that the seeds we plant as teachers may take years to bear fruit, but when they do, it nourishes not just the mind, but also the spirit. I would like to extend my heartfelt thanks to Dr. Indumati Rao, a remarkable educator in her own right and a tireless champion for science education. Her vision and efforts in instituting this award are deeply appreciated by teachers across the country. Madam, your dedication to nurturing the spirit of science and inquiry in classroom is truly inspiring. As science teachers, we are not merely transmitters of knowledge. We are storytellers of truth, messengers of wonder, and quiet architects of the future. Each student we teach carries a spark that can illuminate a corner of the world, and our role is to protect the spark even when it flickers. I have always believed that teaching is not a profession, it is a sacred responsibility. Whether it was explaining Newton's law or watching a young student light up after their first successful experiment. These are the priceless rewards in a teacher's life. In all my years of teaching, I have found that the most powerful lessons are not always found in textbooks. They are found in curiosity, resilience, and the courage to question. And if I have in any way encouraged my students to be fearless in asking questions, to be persistent in their learning, and to believe in their potential, then I consider my journey well worth it. This award is a recognition not just of my individual efforts, but of every teacher who stays up late preparing lessons, who celebrates the small victories of their students, and who continues to teach with heart, even when no one is watching. I dedicate this award to them also. I also want to thank my family, colleagues, and my dear students, past and present. Your support, encouragement, and energy have been the backbone of my teaching journey. To the young educators here today, I offer one thought: teach with passion, lead with compassion, and never underestimate your ability to ignite change. One student, one lesson, one moment at a time. Once again, my deepest thanks to the jury, to Professor Bharat Ratna C.N.R. Rao sir and Dr. Indumati madam, and to the organizers of this prestigious event. Thank you all for this honor. It will stay with me as one of the most meaningful recognition of my life. Jai Hind.
Thank you, Mrs. Singh. Thank you to all the awardees for their heartfelt words. May you continue to inspire your students and your colleagues and lead in your respective fields. Now, I would like to invite our guiding force, Dr. Indumati Rao, who is really a force behind this foundation, who every so often ignites a new direction to the course of action of ETU and the C.N.R. Rao Foundation. Madam.
Good morning, everybody. And see curious faces all around. It's indeed my great pleasure, and I want to take this opportunity to honor one of the greatest teachers, Dr. Professor Kurtigi. Please. Yeah, please. 1 minute, please. Before we actually honor him, I want to say a few words about Dr. Kurtigi. He's a remarkable person. He started as an ordinary teacher long ago in one of the premier schools in North Bangalore. And from there, he explored himself before exploring others. And he found that the greatest joy and the greatest achievement is to empower everybody to realize their potential and to fly free, not be bound by traditions, not be bound by what others expect, but what you can do and what you believe in yourself. And he's the greatest motivator I have seen in my long life, long dedicated life to teaching. And it's my great privilege to honor him for his contributions. Yes. And we normally give Buddha, that is our signature gift. Buddham Sharanam Gacchami, Dharmam Sharanam Gacchami. You know, his class or whatever, his exchange with students is remarkable. You know, how he elicits everything from the audience, from the participants, to finally find that teaching is wonderful and the potential is in every one of you, in every one of us. It's a master class. And I request him today on this Teachers' Day occasion to guide our teachers and participants. And we let us have joint programs where we empower teachers and individuals to become what God has gifted to them. Thank you.
My respectful pranams at the lotus feet of Dr. C.N.R. Rao and Srimati Indumati Rao. Unexpected gifts are more thrilling. I didn't know that this will be there for me. I'm so honored and blessed, ma'am. Suddenly you thought of me. I have completed 52 years of teaching. And I should add, completed 52 years without a moment's regret. I'm honored that I'm a teacher. I pray God that if I have another birth, I should be born as a teacher and nothing else. It is infinite love of Srimati Indumati Rao and Professor C.N.R. Rao. They honored me today, which I never expected today. But there are so many young teachers all over. I only say three things to them. If you remember the three questions, I think we'll all be extraordinary teachers. One is, do you love your subject? Do you love your profession? And third and most important, can you love your students as intensely as you love your own children? If you do that, you are an extraordinary teacher. This message was given to me by Swami Ranganathananji Maharaj, who became the president of the Ramakrishna Mission when I entered into teaching profession. In fact, he was one who brought me into teaching profession in 1972. Amazing man. I only pray God. I always see if there are teacher spectrum. When you complete your education and go, most of the teachers' names are lost in hazy cloud of memory. Some are remembered.
Some have made an impression on you, but you remember one or two with real pleasure and say if you are something today is because of those teachers. It's the end of the two spectrums. On one side, most of the faces are lost. The other side, you feel grateful to people. Which side I want to be as a teacher? If I want to be on the other side of the spectrum, that teachers and students remember you even after you retire or even if you pass away, people remember you. If you want to be that kind of a teacher, only thing is love your students as intensely, perhaps more than what you can love for your children. If you can do that, you'll be extraordinary teachers. I'm honored today, ma'am. It was most unexpected blessings that I got. Thank you so much. Thank you.
Thank you, sir. Now I invite our President, Professor Umesh V. Wagmare, to deliver the presidential remarks.
Thank you. Namaskar, good morning. Bharat Ratna, Professor C.N.R. Rao, Dr. Indumati Rao, the past presidents of JNCASR, the awardees and the jury, and distinguished guests, and most importantly, dear students. Thank you for joining here today to celebrate a birthday, which actually is a celebration of science. People who make a difference in science are being recognized and awarded in this very important day. This is the day, 30th of June. None of us at JNC misses. We always have it in our calendar. It's reflected in our past presidents. All of them are here. We miss Professor M.R.S. Rao, but I'm sure he would have been here with us too. Why? Professor Rao has been an active practitioner of science at the highest level for more than 7 decades. He continues his work even today and has been a terrific figure of inspiration for all of us. We are lucky, privileged that he comes every day to our institute and continue to inspire us through his commitment and terrific efforts to pursue science. Thank you, Professor Rao. It's also a good chance for me to wish him a happy birthday and many more years of continued active science at the excellence and making a difference to all of us around you. Thank you. When you realize he is also joined by Dr. Indumati Rao, she also was a science teacher. She also shares that passion with Professor Rao, and together they have started the C.N.R. Education Foundation, which we, as an institute, JNC is of course very delighted to be supportive of and catalytic in promoting their activities at the center. When they have together established this prize, Outstanding Science Teacher Prize, it has very special significance. They both are dedicated teachers. They have been engaged in science for 7 decades or more. So this prize, in my view, is a true recognition for the teachers. You will see there is a diversity, inclusivity in the choices of awardees. I wish to congratulate all of you, especially on behalf of JNCASR. And please remember, these prizes have been given to you not only for excellence in teaching, but also your significant efforts in science popularization, which, by the way, impact overall scientific ecosystem of India, not just your student, through your students, of course, but not just them when they are with you, because they are the ones who are going to carry the torch of science, which is very much needed in our country, which Professor Rao has been the champion of. Professor Rao has been a great champion of science and probably the greatest champion of Indian science. And we are lucky that you received this award from the C.N.R. Rao Education Foundation. I'll be brief because we are running a little behind schedule. So JNCASR is an autonomous institution under Department of Science and Technology. And it was founded by Professor Rao. So he's also one of the past presidents. In fact, he's the founder president of JNCASR. And very soon it became one of the most sort of accomplished institutes in the country, which reflects on his leadership, vision, and of course, nurturing and commitment to the growth of JNCSR. So we are really delighted to celebrate today the science, which is what Professor Rao represents through his birthday with all of you. I wish to tell the teachers that your innovative tools of teaching and popularization, we should make an archive of it from the C.N.R. Hall of Science, which will be sort of ideally suitable for other teachers in the country to follow, possibly making them available on the website. So we will certainly encourage that activity from the JNCASR as well. And remember, you came to JNC today, your connection with JNC is forever, and we will always welcome you back. And please, we are very committed to doing science outreach, connecting with society at various levels. And the fact that this award is given to high school and pre-university level also is in sync with the commitment we have had through science outreach programs in various parts of India. So please do stay connected, and we look forward to working with you for many years to come. Thank you all for joining today, and wish you all the best. It's a great day today, and I'm sure you will enjoy various aspects. I also thank Dr. Guruprasad to be with us to give a very scintillating lecture later in the morning. Thank you.
Good morning. On this occasion, I join all of you to pray the Lord Almighty that Professor Rao be blessed with many, many more years of active and healthy life. On this occasion, I have something more to announce. What Jayachandra spoke was only one component of what Professor Rao has done, has been doing. Of late, in fact, very recently, we are into formation of a trust. This trust is called C.N.R. Research Conference Trust. It's a very important activity as far as we are concerned. We means the materials community in the country. This particular trust will be sponsoring annual conferences across India, in fact, in remote places. And this trust has just formed. In fact, today itself we'll be signing the papers. And Professor Rao has made a significant contribution to that. May I announce that, madam? Okay, to the tune of 1.56 crore. Is that right? And in addition, he will also be sponsoring the amount required to conduct this year's conference, which most likely is being held at Behrampur. If you know ICER Behrampur, they are likely to host somewhere in the remote place in Orissa. So such is a very noble activity, and it's going to be there for years to come. We used to have such conference in the past with some other name. Then also Professor Rao used to support the conference activity, but now in a mega way, in a big way. And we are so glad that we have taken it up under the sponsorship of Professor Rao and Mrs. Rao. Thank you very much.
Thank you, Professor Kulkarni. Also, thank you, Professor Wagmare, for those presidential remarks. Now, Madam Indumati Rao would like to felicitate our President, Professor Umesh B. Wagmare. He has just taken over, and as he will now be a chief supporter from the administration of JNCASR, we would like to felicitate you for your continued support of the activities of the Education Technology Unit. Sir, please, can you come?
Yeah, on behalf of C.N.R. Education Foundation, I request Professor G.U. Kulkarni to felicitate our current president. Thank you.
As we near the end of the first quarter of today's events, I said the first quarter because after the tea break, we will have an exciting world of asteroids, a talk by Dr. B.R. Guruprasad, followed by lunch, followed by chemistry experiment demonstration for the students. And then in the evening at 4 o'clock, we also have a music concert at the new auditorium. But it is my privilege and pleasure to now accord the vote of thanks. This day's events would not have been possible if not for Professor Rao's and Dr. Indumati Rao's magnanimity. So thank you, Professor Rao and Madam Rao. Thank you to the C.N.R. Rao Education Foundation and its trustees. Special thanks to all our distinguished guests who have come from afar, including Dr. B.R. Guruprasad and Dr. Gururaj Karjagi, the former Secretary for DST, Professor Sharma, our former presidents who have continually supported the activities of the Education Technology Unit and several other activities of the center, Professor V. Krishnan, Professor V. Nagaraja, Professor G. U. Kulkarni. I also thank you, dear students and teachers who are here and who have joined online. I thank my faculty colleagues and the staff members of JNCSR, particularly those of you who have assisted in various aspects of today's events. I wish to thank our administrative officer and his team, Mr. Joydeep Dev. I wish to thank the ETU team who has been very valiantly conducting many activities throughout the year, including Dr. Pattar and Mr. Praveen. I thank the audiovisual team who have been ensuring the smooth conduct of the events today, and the staff of our gardening team at JNCSR for making this place especially beautiful today. Now I invite everyone to join us for tea break outside. Thank you very much.
1 minute, please. I would like to say thank you to Sheba for comparing.
Yeah.
For comparing it very well. Sheba is a very dear friend, and she's also the chair of ETU. Great pleasure, Sheba. From surely there. Surely there. Thank you so much. Okay, okay. No, pleasure. Now I call upon Dr. Vinayak Pattar.
I took already.
Vinayak Pattar, come here. You're too tall. Look here, you're too tall. Vinayak is a very unusual person. He lives true to his name, Vinayak Pattar. He is immovable like a rock. He is a completely self-made individual, one of 12 children, from a family where nobody had been educated before. His mother was the most remarkable lady I have met. She visited us in Hubli when we were there. She educated all 12 of them. There is no illiterate in that family. And she married off 4 daughters, all to educated people. I have not met a remarkable person. She herself was not an educated person in the formal sense, but she was the most educated person I have met. It was my great privilege to meet her with a brood. Really, the whole hall was occupied by the family of Pattars. So, and his father was a goldsmith. You can imagine, he is pure gold. Thank you, Vinayak, for everything. And he is in charge of ETU. and he is going to guide us to greater heights.
Thank you, madam. Last one, on behalf of C.N.R. Education Foundation, is a small token of gratitude to Mr. A.N. Jayachandra for all the guidance and complete support. Yeah, please come, sir.
Well, I want to say a couple of words about Mr. Jayachandra. He is Sarvantariyami, here, there, everywhere, never in one place. And at the same time, I must tell you, his call, what is it called? Identifies a person. His call is, he is busy otherwise. ನಿಮ್ಮ ಕರೆಯನ್ನು ಸ್ವೀಕರಿಸುತ್ತಿಲ್ಲ, ನೀವು ಕಾಯಬಹುದು ಅಥವಾ ಪುನಃ ಕರೆಯಬಹುದು. ಆ ಪುನಃ ಕರೆಯಬಹುದು ಬರೋದೇ ಇಲ್ಲ. He is a wonderful person. He's like our son. He's shoulders all responsibilities and very irritatingly wants to take over everything, which I don't allow. So, Mr. Jayachandra, thank you very much for years and years of companionship.
Okay. Now time for a break, tea break. And thank you very much for your all the cooperation. And I'm very thankful to all the dignitaries. And once again, thank you very much. And we'll meet at a tea, and we'll come back and we'll have a special lecture today. It is an interactive lecture, and it is an illustrious lecture. I am weak little bit. Okay, fine. Thank you very much. And make the tool rule number 2. What rule number 2 says? Follow the rule number 1. Yeah. Okay. Keep quiet. Rule number 1 is you are not supposed to make noise in the auditorium. Rule number 2 is don't forget the rule number 1. Yeah. Rule number 2 says don't forget the rule number 1. Yeah. Yeah, we'll back, we'll come back at exactly 11:40. You have to be here at 11:40. Please keep quiet. I said maintain rule number 2. No, let them go.
brothers and sisters, and we are proud to say that we have a great dignitary. That is, I would like to request our chemistry teacher of 7th.
Now I am standing here the program. First, I would like to welcome Bharat Ratna Professor C.N.R. sir and Dr. Indumati Rao madam. I welcome you heartily, sir and madam. Next, I would like to welcome Honorable Founder sir and Chairperson madam. I heartily welcome you, sir and madam. Next, I would like to welcome Director sir and Principal sir. I heartily welcome you, sirs. Next, I would like to welcome all my dear teachers. I heartily welcome you, teachers. Next, I would like to welcome my dear brothers and sisters on behalf of School Children Students, Parliament, Management, Committee, and one and all. Thank you.
Thank you, sister. शैले शैले न माणिक्यं सुक्तानमोक्तितं ಸಾಂದ್ರನಹಿ ಸರ್ವತ್ರ ಅಚ್ಚಂದನವನೇವನ. ಅಂದರೆ ಎಲ್ಲಾ ಪರ್ವತಗಳಲ್ಲಿ ಮಾಣಿಕ್ಯಗಳು ಇರುವುದಿಲ್ಲ, ಎಲ್ಲಾ ಚಿಪ್ಪುಗಳಲ್ಲಿ ಮುತ್ತುಗಳು ಇರುವುದಿಲ್ಲ, ಎಲ್ಲಾ ಕಾಡುಗಳಲ್ಲಿ ಚಂದನದ ವೃಕ್ಷಗಳು ಇರುವುದಿಲ್ಲ. ಅದರಂತೆ ಸಜ್ಜರು ನಮ್ಮೊಂದಿಗಿದ್ದಾರೆ. ಸತ್ವಭರಿತ ಅನುಭವಿಗಳನ್ನು ಸ್ವಾಗತಿಸಿದ ಧನುಶ್ರೀ ಸಹೋದರಿಗೆ ವಂದನೆಗಳು.
Now it is time to listen the brief introduction about this program. I would like to request our Priyanka Star of 9th standard to the introduction for this program. Sister.
Morning everybody, I am Priyanka from 9th standard and firstly I wish you happy birthday sir. So on every year of June 30 we celebrate Bharat Ratna C.N.R. Rao sir's birthday. Bharat Ratna Professor C.N.R. Rao is not Bharat Ratna, he is also a Chandana Ratna for us. Bharat Ratna Professor C.N.R. Rao supports us to do science outreach program to every year, and he is the inspiration of the school children students and every age students. And on every outreach program, he sends the scientists all over the countries. Now, our Vachana sister and small brothers and sisters take some awards of our icon of our children. He had got many awards all over the countries, and some of the awards had given to us. So thank you, sir, for being an inspiration to all of us. We, the school children students, wish you that. So once again, wish you happy birthday.
Thank you, sister. Bharat Ratna Professor C.N.R. Rao sir has got many awards from many countries. Now I would like to request Vachana sister from 4th standard to say some few awards.
Morning to you all. I am Vachana from 4th standard. Wish you happy birthday, Professor C.N.R. Rao Tata. He has many awards. I am telling you a few awards. Indian Science Award in 2004. Royal Medal by the Royal Society in 2009. Bharat Ratna Award in 2014. Padma Vibhushana in 1985. DSC from Mysore University. Edanapalli Medal and Prize. Royal Society of Chemistry. London Medal. Asian Scientist 100 Asian Scientist. Russia Award. The Order of Friendship in 2009. Thank you.
I have to request Gangotri sister to say few awards.
is the birthday of C.N.R. Rao, sir. I wish you, sir, many returns of the day, sir. C.N.R. Rao, many awards of many countries. I am telling today few of C.N.R. Rao Award. Indian Science Award, Royal Medal by the Royal Society. KSCC Pranapalli Medal and Royal Society of Chemistry, London Medal. Founding the member of the World of Cultural Council, Einstein Gold Medal of UNESCO, Doctor of Science of University of Calcutta. Russia Order to French Fellow to the Royal Society. Scientist, 100 Royal Scientist. National Award, Padma Shri Award in 1974, Padma Bhushana in 1985, Karnataka Ratna in 1000, Bharat Ratna.
Now I would like to request Chandana Sangitya Asthana brothers and sisters to sing the Janmadin Moh song.
Thank you, brothers and sisters.
Now we are at the peak point of this program, that is vote of thanks. Now I would like to request Rushti sister from Maid Chandan to do the vote of thanks.
I am 60. First, I wish you happy birthday, sir. And here of thanks. I would like to into the next I would like to thanks next I would like to thanks producer and director sir. Thanks. I would like to thanks I would like to thanks thanks all my dear management committee and my leaders.
Thank you, sister.
So I'm ready from my side. Vinayak has to come in. Huh? Yeah, we have overshot time. But let it be informal, it doesn't matter. Yeah, still time is there.
Yeah. Good morning to all of you. Are you excited about the talk which we are going to have today on the asteroids? We all live in the Earth, right? And we are always curious to know about what happens out of the Earth. Are you all? So I'll invite Dr. Vinayak Pattar to introduce Dr. B.R. Guruprasad. Vinayak.
Thank you, sir.
Please settle down fast. Okay. Good morning, everyone. Morning, afternoon. Okay, morning. Okay, fine. Fine. Okay. Once again, good morning. It's our great honor to welcome Dr. B.R. Guruprasad, a highly respected scientist, educator, science communicator, and public relation expert. Dr. Guruprasad is currently serving as a director of Jawaharlal Nehru Planetarium in Bangalore. He is also adjunct faculty member at National Institute of Advanced Studies, NIAS, and a member of editorial board of the Journal of Aerospace Sciences and Technology. He worked for nearly 37 years, more than 37 years at ISRO, and where he played a key role more than, he has more than 25, he worked in 25 satellite missions. Okay, he retired as a, yeah, it's a big thing. Okay. It's a really great one. And he retired as a scientist SG and associate director of the Office of Media and Relations, Public Relations at ISRO headquarters. During his career, he's also worked with the space agencies in various countries, okay, especially in the Germany, Japan, France, and USA. And, I'll tell you one thing. Wherever you read some science article regarding ISRO and its missions and satellite space in Canada and English in India, who wrote all those articles? Sir, Dr. B.R. Guruprasad, he popularized, almost nearly 37 years, more than, 3 decades, and he's writing the articles to, popularize ISRO. Everyone heard here that ISRO, what ISRO is now, because of Dr. B.R. Guruprasad, like that person's. Okay, and Dr. Guruprasad has a PhD in space technology policy and holds a special certificate in aeronautics. He is a passionate science communicator. He has written more than 600 articles, as I said, and 13 books in English and Kannada and space and astronomy. The one of his book has been translated into 11 Indian languages, including Sanskrit. Okay, and he has appeared nearly 100 science programs on radio, TV, delivered over 700 popular science talk, conducted 600 exhibitions, and organized water rocket workshop and science quizzes across India. He's very famous in science quizzes for the school children and high school teachers. All the media public relations at ISRO because of him, and he helped bring the space science closer to the people. Okay, his interview and expert opinion are regularly featured in the media. Okay, especially during the major missions like Chandrayaan and Aditya, the missions. And he has represented India in over 15 countries and sharing his knowledge and passion for science education. We truly privileged to have Dr. B.R. Guruprasad with us today. Please join me in giving him a warm welcome. Over to you, sir. Thank you very much once again. I have more than 3 to 4 page profile. I reduced it to 1 page. Sorry. Thank you.
Respected Professor C.N.R. Raoji, Bharat Ratna C.N.R. Raoji, and Madam Indumati Raoji, in their absence, of course, they had their work, so they had to leave. And now their family members are there in their august presence, and in the august presence of Dr. Gururaj Karajagi, the master communicator. I don't want to preempt anything. You know, sir, how capable he is as far as communication is concerned. In Kannada, we say, mantra mugdarannagi maduvudu. That is, he is known for doing such kind of things. Yes, sir. See, in India and in the august presence of all others, Chandana School, Ishwar sir, and all others who have come here, as well as students. First, let me say, though it is tending towards afternoon, good morning to you. Okay. So morning will be more activity will be there. Afternoon means it plateaus. Okay. That kind of thing. So all said and done. So I am really honored to have been invited here on this special day when Bharat Ratna Professor C.N.R. Raoji is celebrating his 91st birthday. Okay, that's why when I was invited for this, I really agreed readily. Okay, without wasting time, let me go to the topic of today. No, today is being observed, not celebrated. Today is being observed as Asteroid Day. Okay, June 30th of every year since 2015. Okay, United Nations under the leadership of United Nations from 2016 to be more precise. June 30th is being every year as this day, June 30th, 1908. Okay, a space rock came and exploded over what is Siberia today, in fact. Okay, so over a place called Tunguska. Okay, that's why it is known as Tunguska event. There was an air burst. It didn't reach the ground at all. It exploded in the air, and believe me, 80 million trees were destroyed. That is 1,200 square kilometers area of forests were destroyed. Okay, rather was destroyed. And the thing is that space rock was hardly about 60 meters or something like that. That's all, 60 meters. And such space rocks in the history of the earth, okay, they have come towards the earth, rocks of varying sizes, space rocks of varying sizes, they have come and hit the earth, and sometimes, rarely, they have obliterated almost all of life. I'll give you the details. But anyway, even as early as 2013, okay, again over Siberia, one more piece of rock, space rock, it came, and it was about 20 meters or something like that. Okay, it came over a city in Siberia called Chelyabinsk. So again, it exploded, but fortunately, nobody died. At least thousands were injured. So it is imperative on our part to know about these space rocks and the threat from them. Even today, in the early part of this year, people were thinking that an asteroid which was discovered in December 2024 last year would come and hit the Earth in 2032. That's very small, again, not a very big one. Okay. So whatever was there over Chelyabinsk in 2030. So the threat from space rocks is ever present. Let us be aware of it. But these so-called space rocks, they can help us understand the way in which the solar system had its origin and its evolution, its history. And they help us understand how life might have originated on Earth and evolved on Earth to a certain extent. So come with me, we'll go on a journey towards the space rocks, which we respectfully called as asteroids. I'll tell you what is asteroids. In fact, the exciting world of asteroids, That is the thing. Look at Earth, planet Earth, on which we are all living. So it is quite comfortable. This is not the case with the other members of the solar system, be it on Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune. It is not like that. This is the heaven on which we are living, and this is the third rock from the sun. The first two rocks are Mercury and Venus. The third one is Earth. Fourth one is Mars, okay, in the inner solar system. So what does the solar system consist of? Let us go to some fundas, okay. What does solar system consist of? It consists of the sun almost in the central part, okay. 99.8% of the mass of the solar system is contained in the sun, okay. Then there are 8 large bodies which are circling the sun, which we call as planets, 8, okay. And much smaller worlds are circling those planets, and we call them as satellites. Apart from that, we have heavenly bodies like which are like broomstick-like, and they are comets. Okay, and apart from these things, there is another class of bodies called asteroids. Okay, asteroids. I will define them as to what they are. Asteroids. Today we know at least 13 lakh of them. Okay, 1.3 million asteroids today we know at least, but there are millions to be discovered. Much smaller one, and mostly they orbit between the orbits of Mars and Jupiter. Okay, so these are the 9 planets from the solar system. Mercury, the first one, it is on the average at a distance of 6 crore kilometers. I'll restrict myself to crores and lakhs, with which we are familiar. On the average, Mercury is 6 crore kilometers from the sun. Venus 11 crore kilometers from the sun. On the average, Earth is 15 crore kilometers from the sun. Mars 23 crore kilometers from the sun. Jupiter 78 crore kilometers from the sun. Saturn 145 crore kilometers from the sun. Uranus 285 crore kilometers from the sun. Neptune 485 crore kilometers from the sun. Now you see here distances are not much, but between Mars and Jupiter, see, Mars is on the average at a distance of 23 crore kilometers from the sun. Jupiter is 78. So 50 crore kilometers of a vast space is somewhat vacant, people were thinking. One of them even questioned, how can the Lord keep universe like this? In fact, okay. Now, this is the asteroid belt, so-called asteroid belt. It starts at around 2.2 times the distance between the sun and the earth and ends at 3.2 times. Okay, that is the kind of. The average distance between the sun and the earth is called as 1 astronomical unit, that is 15 crore kilometers. So this earth is at 1 astronomical unit. This asteroid belt is between 2.2 and 3.2 astronomical units. If all the asteroids were to be in the asteroid belt itself, it would have been okay, but that is unfortunately that is not the case. There are asteroids who share the orbit of Jupiter. Okay, they are known as Trojan asteroids, in fact. Okay, Trojan asteroids, and that is okay. Jupiter is quite far away, but there are asteroids known as near-Earth asteroids. On their journey around the sun, they come near the Earth many a times. One class of such asteroids are known as Apollos, Apollo group of asteroids, because the first asteroid with such an orbit which was discovered was Apollo. Its name was Apollo. Look at that, it is crossing the orbit of the Earth. If Earth were to be there in the same spot where it crosses the orbit, then it is not good for us. Similarly, there is another group of asteroids, again, which cross the orbit of the Earth here and here. They are known as Atens. Okay, Aten group of asteroids. And third group, which doesn't cross the orbit of the Earth, but they come very near to the orbit of the Earth. They are known as Amors. This is the orbit of Earth. They come very near. So all these things, they are somewhat dangerous. All of them, I don't say, in fact, sometimes, rarely they come very near to Earth, and because the Earth attracts gravitationally, okay, because of the gravitational interaction with the Earth's gravitational field, and they sometimes do enter the Earth's atmosphere. It is estimated by scientists that every day one car-sized asteroid enters, it seems. But anyway, nothing happens because those pieces of asteroids burn up in the atmosphere. Earth has got a very thick atmosphere, so they burn up, fortunately. In the case of the moon, it is not the case. This is not so. That's why how many craters you can see on the moon. It is full of craters only. But on Earth, that is not the case because you have plate tectonics, that is lava wells up, everything is moved away, erosion is there, okay, weathering is there. All these things will obliterate the craters for the most part. But in our country, there is a place called Lonar in Maharashtra. You have such a crater made by an asteroid. Okay, now look at the size of the asteroids. See, this is the moon. Okay, moon is 1/4 the size of the Earth. 3,476 kilometers is the diameter of the moon. Earth is 12,756. So look at that. Compared to the size of the moon, the largest asteroid is 1,000 kilometers in diameter. That's all. 3,476 for the moon, 1,000 kilometers here, and this is much smaller. So the thing is, 5 asteroids are very large. All others are smaller and smaller and smaller and smaller. And when it comes to the mass of all these asteroids, when you put them together, okay, their mass totals only 3% of the mass of the moon. That's a 3% of the. Then how massive is the moon? If you put 80 moons in terms of mass, it will be equivalent to 1 Earth. 3% of that mass means that much. What are these asteroids? Once upon a time, scientists were thinking that they are the pieces of a planet that exploded. But today they think they are the pieces of a would have been planet which never formed. So that is the current view. So let us go to the, next one. So this is the way asteroids, they are moving. And look at that, whatever is shown in the pictures, they are not painting or anything. This is the way the picture of the asteroids. I mean, the asteroids look like many of them, but they have been put in an animation, that's all. But the way in which asteroids look, it is the same. Exactly. These are not the paintings. These are the real pictures taken by spacecraft. So how did asteroids, how did scientists come to know about asteroids? No, I don't have time much. That's why, there was a mathematical curiosity in the 18th century. There was one astronomer, German astronomer by name, Johann Titius. Okay. He started a mathematical curiosity. You write numbers, 0, 3, then double it, 0, 3, 6, 12, 24, 48, like that you write. Add 4 to them. 0 plus 4 is 4. 3 plus 4 is 7. Divide each number by 10. So first will be 0.4, 0.7, 1 like that. So that represents the distance, average distance from the sun of each planet from Mercury onwards, okay, in astronomical units. So when that so-called rule and law, there was a law means, first of all, it has to be a hypothesis. When it is proved, then only it is law, but people were calling it as law. Okay. But anyway, there is no proof for that today. So in that, whatever was predicted, there was a gap between Mars and Jupiter. It represented roughly the distances. It was purely coincidental. So many people were searching for a planet between Mars and Jupiter. There was one Christian priest, okay, as well as astronomer by name Joseph Piazzi, or Joseph Piazzi. Okay, he was in Sicily. He was in a place called Palermo, the capital of Sicily, and he was searching the night skies. He was not explicitly searching for a planet between Mars and Jupiter. He found something which was moving somewhat. Moving means not like this. Slowly it was moving. And this was 1801, January 1st. And he found such a thing, and first he thought it was a comet. Then slowly, then he fell ill and he didn't observe again. Again, the December of that year he observed. But you may try to understand how it is moving, but you have to fit an orbit to it. Otherwise, why should I calculate the orbit of that? Otherwise, I will not know at what time where it will be. So for that, there was a very brilliant mathematician by name Carl Friedrich Gauss. Any one of you have heard the name Gauss? Gaussian theorem is one of the wonderful mathematicians in ever, I would say. Such a great fellow. Okay, so he developed a method in which even with small observation, small period of observation, if he takes the information, he can calculate the orbit. He could able to calculate the orbit. He developed a method like that. Okay, Sir Isaac Newton was also like that. When he was dealing with rapidly varying quantities, there was no mathematical field which treated that. So what? He developed a field of mathematics, which he called, at that time it was called as flexions. Today, what is the name given to that? Anyone know? Calculus. Yes, that is the thing. There was yet another great mathematician who was a contemporary of Newton. Okay, his name was Leibniz, Gottfried Wilhelm von Leibniz. He was the other person. If you write dy by dx today, he is the one who started that notation. That is Leibniz. Anyway, he was P at C. He was the one who discovered this. And when the orbit was calculated, it was moving between orbits of Mars and Jupiter. Oh, that was the planet. That was not the case. Because next year in 1802, one more small heavenly body was discovered in this, almost in the same orbit. Second one. Then in 1807, two more were discovered in the same region. So it could not be a planet. Okay. So first one was called as Ceres, second one Pallas, third one in 1807 Juno and Vesta. Then William Herschel, have you heard the name? Okay, he was the man who discovered Uranus using a telescope. He discovered, he actually gave the name asteroids to these bodies. Asteroids means star-like. Why? If you turn a telescope and focus it towards a planet, it expands into a globe. Any planet, Uranus, or even, let us say, Mars, Venus. But these bodies, Ceres, Pallas, Juno, and Vesta, they were still points of light even for large telescope. So that means they were very small. So William Herschel suggested the name asteroids, that is star-like. They are like stars even in large telescope. So that is the word asteroid which has come. So asteroids, largely they are in the orbits of Mars and Jupiter. Okay. In the 19th century, a lot of asteroids were discovered. By 1868 or so, already 100 asteroids had been discovered between Mars and Jupiter mostly. And in 1891, Max Wolf, he invented astrophotography. Instead of watching continuously, you could able to take the pictures and compare them, and more asteroids were discovered. And by 1920, 1,000 asteroids have been discovered. By 1981, 10,000. By 2000, 1 lakh. Today, we know there are at least 1.3 million asteroids, at least. Many are yet to be discovered. And let me tell you, some of them, only some of them, they come very near to Earth. They are dangerous. Okay. Let me say, see, telescopes for watching all these things. Okay, how long? Humans are very impatient. They want to go and explore the universe on their own. So, on October 4th, 1957, a metallic sphere, which was hollow, was launched into space. Its name was Sputnik 1, and that ushered in the space age. In fact, it heralded the space age. Look at the rocket there that went up, and that was the entire human history changed that day. So humans had access. So this is beep, 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 beep. So that is the way Sputnik went to space and ushered in the space age. And after that, many spacecraft have been launched towards asteroids also. But it took 15 years for humans to launch some spacecraft towards the asteroid belt, not for exploration. Many scientists were thinking, this is Pioneer 10, this spacecraft, NASA spacecraft. But in order to go to Jupiter, you have to pass through asteroid belt. They were thinking, Asteroids are going to finish off the spacecraft by hitting them. This was not the case. Today, we know the average distance between two asteroids is 1 million kilometers. The chance an asteroid, when you are making a spacecraft to pass asteroid belt, the chance that an asteroid will come and hit it is 1 in billion. 1 in 1 billion. So it's so, space is so vast. Anyway, it passed through, it didn't explore, and this is the way. It passed through the asteroid belt. Asteroid belt is this, went towards Jupiter. In 1972, roughly it crossed. Then, these asteroids, for scientific reason, for astronomical curiosity, they were being explored. But in 1980, things changed. Many of you, I was talking to Dr. Jayashree here just now about the history of the Earth. In our lifetime, we say we have childhood, we have youth, we have middle age, we have old age, final death. That is inevitable. So similarly for Earth, okay, the early history of the Earth, middle history of the Earth, and the present history of the Earth. The earliest age of the Earth, the era of the Earth, is Precambrian, let us say. Okay, then Paleozoic, Mesozoic, and Cenozoic. Cenozoic is the present age. In the Mesozoic, okay, that from 225 years to roughly 66 million years. Okay, earlier they said 65, now it is 66. They have refined it. There were 3 subdivisions to that called Cretaceous, Triassic, and Jurassic. Or Triassic, Jurassic, Cretaceous. Okay, so at the end of Cretaceous, all the dinosaurs, okay, they became extinct, all except for the ones which were flying. That means non-avian dinosaurs. Okay, all of them became extinct. 75% of the life was extinct around 66 million years back. Then there were 2 people in the United States, father and son. Both of them were Nobel laureates. Okay, Luis Alvarez and Walter Alvarez. In 1980, they proposed the theory that at that time they said 65 million years back, an asteroid came and hit the Earth. And that was the reason for the extinction of the dinosaurs. From that time onwards, people were scared. Scientists also became very curious. Common man is different. Scientists are cautiously, they want to approach anything. So that is why asteroids acquire more importance. Yeah, this is the way. Tyrannosaurus Rex was actually terrorizing everything. That was also extinct. Okay, this was an ornithopod, that is like bird. So there were many sauropods also, like lizards kind of thing. All of them became extinct, which were there about 66 million years back. And before that, the thing is, if any alien life form, alien intelligent life form, if it were to come to Earth and see, it would have concluded that this planet Earth is a planet of dinosaurs. Where were the human beings? Nothing. We belong to the class of mammalia, okay, mammals. So, but mammals were nothing in front of dinosaurs. They were the most dominating species. And what happened? Let us see. 66 million years back. Sorry about this. Look at that. This might have happened 66 million years back. Look at the Earth. Earth was fine. And you see, different kinds of asteroids are there. One of them, which was, let us say, 10 kilometers in diameter, it came and boom, it hit the Earth. Okay, it hit the Earth in a place. Today it is in Mexico, a place called, okay, Yucatan Peninsula. Okay, the exact place is called Chicxulub. That is where it went and hit. That was not like the Chicxulub, whatever is today, was not like this. Anyway, that came and hit, and that gave rise to the extinction of dinosaurs. Okay, sorry. Okay. Yeah, look at that. The dinos were bystanders. They could not do anything. And they could not understand. They were dumb somewhat. At least they are not as intelligent as us. Okay, that's the way it is. And now let us see. yet another thing. So sorry. Oh, I don't know. Something is happening here. Ah, this is the way the asteroid hit, and you know, this asteroid was 10 kilometers in diameter and hit the Earth at 50,000 kilometers per hour. So then what happened? Oh, it's not. Why it's not working? Ah, no. Okay. Here. So this is the way. See, when it hit the Earth, there was a huge crater and lot of dust and material, even rocks, they were thrown out. Entire sunlight was blocked by the dust, and these rocks came down like missiles. So all these things gave rise to the extinction of dinosaurs. Till that time, mammals were minor in the sense. Okay, they knew where in burrows and such places. This is a rat kind of animal called shrew. Let us say Shakespeare's Taming of a Shrew. You might have read about it. You know that the shrew was a mammal, and since dinosaurs, which were dominant, became extinct, then that gave rise to mammals, primates, and humans ultimately. Okay, from Lucy onwards. Okay, to present day Homo sapiens sapiens. In fact, so that's the thing. Now we are all there. So that is the present status. Now let us go back to asteroids. Why asteroids are important? Are we threatened by asteroids? That is why we have to study them. Not only for that. Asteroids are like time capsules. They can make us understand. They can help us understand. They enable us to understand the origin and evolution of the solar system, our own planet Earth, the moon, everything. So asteroids have to be studied. And this subject is more dearer to Professor C.N.R. Rao, sir. And you know, there is a theory that many of the chemicals which are essential to life, organic chemicals, they were brought to Earth by asteroids. In some way, asteroids were responsible for feeding life on Earth, seeding life on Earth. This is a theory, I am telling. But in 2020, one American spacecraft called OSIRIS-REx, it explored an asteroid. I'll show you the picture. And when they analyzed whatever the material that was brought back, they found 14 amino acids in there. Okay, that's the way. Yeah, let us say. Now, after Luis Alvarez and Walter Alvarez, when they said that dinos became extinct because of asteroid, so NASA put in lots and lots of money. Okay, not as much as human space flight, but still they put a lot of money. And this spacecraft called Galileo was sent towards Jupiter, and this was the first spacecraft to explore an asteroid, Galileo Galilei. And this is the spacecraft. You know, Galileo, because of his passion for science, his support for scientific development, he had to suffer a lot. He was even shown the torture instruments, in fact. But paradoxically, this spacecraft named after him also suffered a lot. That I can speak for 1 hour. Okay, but ultimately it triumphed. Anyway, even in that state, it took a pic when it was passing through the asteroid belt. It took the picture of this celestial potato called Gaspra. This is the first asteroid which humans saw. Okay, picture of an asteroid, Gaspra. Okay, Gaspra. So this is only 18 kilometers in diameter. This picture was sent by Galileo spacecraft. Look at that, how many craters are there. Then, next year, 1993, it sent the picture of another celestial potato. This looks like real potato, isn't it? In fact, okay, this is the second asteroid to be explored. This is about 60 kilometers wide from here to here, 60 kilometers. This is called IDA, IDA. But the strange thing is, look at the universe. It has got a satellite which is 1 kilometer in diameter. This itself is 60 kilometers, that's all. But it has a satellite which is 1 kilometer in diameter. Earth is 12,756 kilometers in diameter. It has got a moon, 3,476. This is a tiny stuff. Look at the universe, how it is. Okay, now look at that, how IDA looks at different angles, how it looked to Galileo spacecraft. You can see, that's the way it is. Then, anyway, Americans sent one spacecraft towards an asteroid called Eros, E-R-O-S, named after the Greek erotic god. And Americans do a lot of things which from public relations point of view. So this asteroid was to be explored by a spacecraft called Near Earth Asteroid Rendezvous. Okay, rendezvous means meeting, that's all. So this is the spacecraft they launched, and this was the asteroid Eros. Okay, this is not very big, 34 kilometers in diameter, that's all. But they put this Near spacecraft into an orbit around Eros. Eros is named after the Greek erotic god, I said. Fittingly, they made it to orbit Eros on Valentine's Day, February 14th. That's the way it was. That is what NASA did. Okay, then the spacecraft also landed later on the surface of Eros. Okay, you see, step by step, humans are learning more and more about asteroids. Then Japs came. Japanese, they sent their spacecraft, okay, to explore a near-Earth asteroid called Itokawa. Hideo Itokawa was the father of the Japanese space program to a certain extent. Fortunately, he was at Trivandrum. He trained many of our space scientists because he was a great friend of Dr. Vikram Sarabhai. He came and trained, and he went back, and in his honor, this asteroid discovered by Japan has been named Itokawa. Okay, the name of the spacecraft is Hayabusa. Have you heard, any of you? Yeah, everybody has heard. When this thing happened about 20 years back, when I was at home and I was telling, there is a spacecraft called Hayabusa. My son, who was very young, he said, Hayabusa. You know the name? Even kids are knowing about Japanese spacecraft name. I was thinking, oh, this is Suzuki Hayabusa, it seems. So that is the motorbike. That's why everybody knows. Okay, Hayabusa means peregrine falcon, in fact. So that is the name given to that spacecraft also, Hayabusa. Okay, so anyway, this is Hayabusa spacecraft. I'm not interested in motorbikes. I'm interested in spacecraft. Yeah, so this went near Itokawa, collected samples, brought back. See, you can learn a lot. Okay, that's the way. This is the precious material contained in a capsule like this. It was brought back to Earth automatically. Okay, then next, Japan again, second time in the 2010, in the decade 2010 to 2020, that decade, another near Earth asteroid which is small, about 300 meters or something like that. Okay, wide. This asteroid is called as Ryugu, R-Y-U-G, Ryugu. Okay, and the spacecraft which went there was Hayabusa 2. Okay, again Hayabusa, look at that, how it went and collected the samples there. Okay, all these things. Why do we do all these things? We have to learn a lot about asteroids in order to protect ourselves, as well as to learn about the solar system. Look at that. That is the way it. Look at that. That is the way boulders looked on the surface of the asteroid. Can you get these kind of things from any telescope from there? Impossible. You have to send this robotic spacecraft. These are the robotic human messengers. They had human eyes. So they have taken the picture. Then it was the turn of the Americans. This time they sent already the Eros, they had explored. Okay. Then again in 2017-18, around that time, they sent their spacecraft to an asteroid. Again, it's about 200 meters, 250 meters wide. Its name is Bennu. It is not Kannada Bennu. Okay, not that. It is a mythical ancient Egyptian bird, Bennu, B-E-N-N-U, Bennu. Okay, this spacecraft which explored it, you see, collected samples from that, okay, and brought back. Its name was Osiris Rex. Okay, it's a very big name, Osiris Rex. Okay, this spacecraft has been targeted towards some other asteroid now. Look at that. This is the way it collected the samples from Bennu. Okay, this is the asteroid I told. When they examined the material brought back by Osiris Rex, they have found it contains 14 amino acids in Where can you get such thing? Fine. Okay. Now it is redirected towards some other asteroid. I will come to that. Okay. So then, the largest of the, I told you 1801 January 1st, Joseph A. Piazzi found a heavenly body which is called as Ceres. I told you that was the first asteroid. So NASA sent a spacecraft called Dawn, okay, to an asteroid called Vesta. So these are the four large asteroids: Ceres, Pallas, Juno, Vesta. First it explored Vesta, then it explored this one, Ceres. Ceres is a 1,000-kilometer wide body, which is not only an asteroid, it is a dwarf planet like Pluto. Okay, it is also classed. Now let us go back to dinosaurs. Anyway, I told you, dinosaurs were dumb. They could not do anything. When an asteroid came, 10-kilometer wide rock came, hit the earth and decimated them, they could not. They were passive. But human beings are not like that. But human beings have also observed there is a huge crater in Maharashtra. I said there is a place called Lonar to have a crater. On the other hand, one of the most famous craters anywhere in the world is the Great Crater of Arizona. In fact, okay, 50,000 years back, a piece of an asteroid came and hit. And you know how big is? I have visited this place in America. It is 2.1 kilometers or even more in circumference and nearly 600 meters depth is. They don't allow you to go inside unless you are a geologist. But there are observation towers. I too observed and came back. It was what an experience. This is what even small pieces of asteroids can do. Now in 2013, look at that, a place called Chelyabinsk. I told you, first we are celebrating Asteroid Day because in Tunguska in 1908, the hit was there. In 2013, one guy is at the traffic signal. Look at that, what he is seeing. How the piece of an asteroid comes and hits. You see, he stops at the traffic signal. Look at that. It is only about 30 to 30 meters. That's all. Look at that, the way in which it is coming. Nothing could be done. No, it was not detected at all. Yeah. It went and there was an air burst. It didn't hit the ground. No, 5 to 10 kilometers above it disintegrated. And the air blast was there, so that damaged the entire city. This guy has taken picture and he has taken a turn towards right. He is going away again without knowing what it was. Okay. Okay. Then all said and done, humans are not like dumb dinosaurs. They have the technology. They are creative. Okay. And they are capable of taking revenge on asteroids. That revenge took place in 2023. NASA launched a spacecraft called DART, Double Asteroid Redirection Test. DART. DART means whatever we throw like this. That is also DART. Anyway, NASA is very good at public relations. That does a lot of things. So you see, this is the thing. Down this spacecraft, and now I'll show a video of half a minute. Look at that. That is DART, how it was launched. Okay, on a SpaceX rocket. Yes, the spacecraft went to space, unfurled its solar panels. Okay, look at that. It has huge solar panels because it has got an ion rocket engine. It requires electricity. Okay, it's very efficient. So camera, this one, okay, cover has been ejected. Yeah, see, it was directed, DART spacecraft was directed towards an asteroid called Didymos. Didymos, okay? Didymos is being circled by a small satellite asteroid called Dimorphos. Didymos and Dimorphos. Didymos is 780 meters wide. Dimorphos is 160 meters wide. See, this is Didymos. This is Dimorphos. Okay, they are near Earth asteroids. See, this spacecraft navigated it towards Dimorphos. Boom, hit. Okay, there was a direct hit on Dimorphos. Didymos and Dimorphos system is not threatening Earth now. That is why NASA chose them. They wanted to test this kinetic impact technology, you know what has happened. I'll show you a real video of how it was. Look at that. See, this is in the frame of the camera taken by the spacecraft. And look at that. This is Didymos, that is Dimorphos. See how till the last moment the camera has taken picture, till it went and hit, okay, on a suicidal mission, okay, dark spacecraft. Now you see Didymos has gone out of the frame and Dimorphos, yeah, coming near, yeah, it hit. See the frames, how they are coming. Till now that was the frame which went out because it hit and disintegrated. You know what has happened? After it hit, they wanted to test. What they wanted to test was Didymos is there. Dimorphos is circling the Earth. Circling Didymos. Can we reduce its orbital radius a little bit? Can we change its orbit? That is what they wanted to test. And to the satisfaction of all, Dimorphos was taking 11 hours 54 minutes to go around Didymos before this impact. Now the orbit is so changed, it is taking 11 hours 32 minutes. What a great thing, really. Kinetic impact technology has worked. So we need not be that scared now. So we have the wherewithal to protect ourselves. Okay. Anyway, this is a ground-based telescope which has taken the picture. Look at the way in which it went and hit. Okay. So now what are we doing? Very quickly, I will go in the next 5 minutes. I want to finish up. What are we doing to protect ourselves from asteroids? One thing is, first we have to make a survey, find them out, calculate their orbit, be aware, continuously track them. There are so many telescopes all over the world, and there are satellites in space also. One of them is called NEOVOICE. Okay, it was a cosmological spacecraft. In fact, to study something related to cosmology, they sent it. But after some time, they made it to hibernate, put to sleep. Again, when they woke it up, they used for asteroid answer. So that is one thing. And now, I repeat, in the DART mission, we are able to successfully change the orbit of Dimorphos. Okay. Then how much of effectiveness is there in that? Of course, pictures, all those things we saw. But another thing is how effective it is. To know that European Space Agency is sending a spacecraft, okay, already it has launched it. It is going and examining how are things there. They are spending millions of dollars for that, means how important it is. It is called as HERA, H-E-R-A, HERA. And asteroid threat is not going away anyway. Threat in the sense, not that they will come and hit. Possibility, probability, that is the kind of. There is an asteroid called Apophis. You might have read about it. Okay, it's about 1,200 feet in diameter. First, when it was discovered in 2004, it was estimated that it will hit the Earth in 2029, April 13th. They said. Now, anyway, they have recalculated it and it's not going to hit. But believe me, it is going to pass by Earth at a height of only 32,000 kilometers per height, 32,000 kilometer height. From the Earth, from here, 32,000 kilometer high, it is going. Our geostationary satellites like INSAT, okay, NAVIC satellites, they are at 36,000. In fact, just below that, they are going. So all said and done. So that is why this spacecraft called Ramses, that is what Europeans are launching to go to Apophis and study it. In fact, I am sure that when it is passing that 32,000 kilometers from the Earth, it is going to be stretched like anything. Gravitationally, it will be distorted. So some material may come out. They want to study that. To understand that many of you have heard that Lucy, they gave that name. This is going to, this Lucy spacecraft is going to, not to one asteroid, it is going to Trojan asteroids. I told you in the beginning itself, there are asteroids which share the orbit of Jupiter. Okay, this is the Lucy spacecraft, and it has already explored Donald Johanson, asteroid Donald Johanson. Okay, the man who discovered real Lucy there, that anthropologist. So this is the one. This year, April, it has gone. Okay, now it is good. Now, as I told you, asteroids are going to be mined. All of you, some of you might be participating in that. Who knows? In fact, if you are inspired by this, and you can see maybe in movies like Armageddon and such things, you can go and see astronauts going and doing all sorts of things. Okay, Tom Cruise and others are even. Okay, that kind of things, whatever is science fiction today, tomorrow it will be science reality. So you can see asteroid is being actively mined here. Okay, Earth is quite far away. Okay, so then let me conclude. See, I told you already we have been successfully through kinetic impact, we have changed the orbit, we have deflected. But for all the asteroids, you can't do that. If you actually detect an asteroid very late, one method which is available to you is you send a nuclear weapon there. Near that, you explode. Okay, it will not shatter the asteroid. On the other hand, it will push it out. The blast wave will push it out. That is what is being shown there. Of course, some debris will be there, or you pulverize it. But these things are not easy. Lots and lots needs to be learned in this regard. And people are always uneasy to send nuclear weapons to space. So it's not easy, but when your survival is at stake, you have to take certain drastic measures. So, or you use lasers even and pulverize the asteroid. So all these things are being thought of. So asteroids are important from the point of view of economy, from the point of view of science, from the especially astronomy as well as biology, and to ensure our survival. So from all these points of view, asteroids are very essential. The study of asteroids, the exploration of asteroids is very much essential for us Earthlings who are comfortably living today, and we have to be always vigilant, okay, about asteroids. So asteroids are double-edged weapons in the sense they have two, like Dr. Jekyll and Mr. Hyde. Okay, they were responsible for the origin and evolution of life, some scientists say, but of course they have decimated much of life through their impacts in the history of the earth. So let us be ever vigilant, we earthlings who are comfortably living here, and learn more about asteroids. Okay, on this asteroid day and on the day of the celebration of the birthday of Bharat Ratna C.N.R. Rao, I'm very happy to have come and given a talk here in the presence of Karjagi sir. So thank you very much for this, and Now, in the next 10 minutes, if you have any questions, you can ask me in English or in Kannada or in Konglish, all the three in fact. So any one of them, don't hesitate, ask the questions, ask the questions.
Check.
Yes, that boy there.
Check.
Yeah, I'm happy. The first question
Yeah.
has come quickly.
Sir, we have found something called as Oumuamua.
Yeah.
Is it like a spaceship or like it is a normal rock?
Okay.
Some
Yeah.
scientists are
Yeah, I do understand. See, what he says is one asteroid kind of a body by name Oumuamua. Okay, that is a Hawaiian name they have kept. Okay, they have found it. It is unlike asteroids, it is like a cigar. Okay, that kind of thing. So many people are telling, it is an extraterrestrial ship and all those things because its orbital path, okay, it went near the sun, and again when it was going back, it was discovered its velocity is so high and its path is so unique, it would have come from outside the solar system. I'm not sure about it. Much information has not come out. I feel that it might be a rocky body only. Good question anyway. That is not like asteroids. From outside the solar system it has come. Okay. Beyond what we say Oort cloud, in fact. Okay. Yeah. Any other question? Yeah, ma'am, please. Yeah.
I read somewhere that previously the Earth was straight. Now it is tilted. It is tilted now.
Yeah.
Previously it was straight. Some asteroid hit it and it is tilted now.
Yeah.
Is it true?
I mean,
Is there any study?
what people who specialize in this, they are telling that I can say. Is it true means I cannot qualify it. I will tell you. Okay, no problem. Okay, let me be modest. See, Earth came into existence 4.5 billion years back, 450 crore years back. Then solar system at that time was a chaotic place. Now we have 8 planets. There were more than 100, it seems, or 300 at that time. So Earth was there already. It was in a molten state, and slowly it was cooling. So at that, Earth was in its primary school still. Okay. So at that time, a body which was of the size of Mars called Theia, they call Theia. It went and hit the Earth at grazing at a particular angle. The Earth was knocked off from its vertical position to a certain extent, and the top portion of the Earth, it got pulverized, and so much of dust went up, and it started circling the Earth like the rings of Saturn. So say the scientists, not me. Okay. So the thing is, after that, within about 1,000 years or even earlier, all these things coalesced and formed what is today we call as moon. Okay, that this is one of the theories which is currently being accepted because the rocks brought by Apollo spacecraft, they were responsible for the putting forth of this theory. But yes, it could be the thing. It could be the thing. Yes, that is.
Good afternoon, sir.
Good afternoon.
Sir, my question is, we always seem to say that Aditya L1. So why we choose L1 or L2, L3? Could you mention what are the 5 points?
Yeah, it is out of today's topic. It doesn't matter.
Yes, sir, thank you.
Say Aditya L1. L1 is the tail, Bala. Okay, for Aditya. Aditya is the name of the sun. L1 it is at L1 Lagrangian point. In any system in which there are 2 large astronomical bodies. Okay, there was a French mathematician by name Joseph Louis Lagrange. Okay, his name Joseph Louis Lagrange. Okay, his name has been given to the point. Okay, where this L1 Lagrangian point, there were 5 Lagrangian points, L1, L2, L3, L4, L5. L1, why we have chosen is, we have to always see the sun. You can comfortably look at the sun 24 hours a day on the one side. You can point your antenna, transmission antenna towards the Earth on the other side. And you can minimize the expenditure of fuel to stabilize the spacecraft. Okay? Actually, it is not at L1 Lagrangian point. L1 Lagrangian point is there. Around that, there is an orbit called halo orbit. It is around a halo orbit around L1 Lagrangian point. James Webb Space Telescope is at L2 Lagrangian point, not L1, because it has to see away from it. As far from the sun as you are, it is good for that kind of observer. Here you want to study the sun from a relatively nearby distance. Okay, that is that. Okay.
Okay. Last question.
Yeah.
Good afternoon, sir.
Yeah.
Sir, my question is that is there any possibility of viruses or any kind of bacteria existing on asteroids? And if yes, like how it will?
See, amino acids have been found. Okay, amino acids are the building blocks of proteins. Am I correct? Okay, that is the kind of thing. So life per se has not been discovered in asteroids. Okay, ingredients of life have been discovered. Okay, that kind of thing. But in our atmosphere, many of the bacterial species, new bacterial species have been discovered in Earth's atmosphere at very great heights. So one theory is that life is being seeded, they say, but these are all controversial. Unless most of the people accept it, it will not become a theory. Could be a possibility, I'm not sure about it. More data is needed. In 1996, one meteorite was examined by NASA. It was found in 1984. That is why ALH 84001, they called it. It was found in Antarctica. When NASA scientists analyzed it, they found something, it looked like nanobacteria. Oh, we have found, and that meteorite had come from Mars, no doubt about it. See, long back there might have been some asteroid might have hit Mars, and some rocks were thrown out, and they were orbiting Mars, or they had gone away from Mars, and one of them accidentally came near the Earth, entered the Earth's atmosphere and survived, and it might have fallen. There is no doubt about it. It was from Mars, but it contained life, they said. And even Bill Clinton, who was the president of the United States at that time, what a time at which we are all living, he also gave a statement. But now they think that it was not nanobacteria or anything which was found inside. They could able to explain it through inorganic means itself. So these are all, wait for some time, some more data, let it come. For the time being, it is only an educated guess. Thank you. Thank you very much. So I'm ready to answer another hour for questions, but anyway, you have other programs. I don't want to disturb them. So it's very nice that all of you could able to hear this. Thanks a lot. Thanks to Vinayak and all others who have been responsible for this.
Thank you very much, sir. It was wonderful and brainstorming talk. On behalf of C.N.R. Education Foundation, we have a token of gratitude. Now I request Mrs. Suchitra, Professor C.N.R. Rao's daughter, and I request her to give the memento.
Thank you. My pleasure. Yeah, she came. Yeah. Thank you. Oh. Thank you. Oh. Yeah, I'm very happy Dr. Karjagi sir is for this lecture, means so nice, really. Similarly, in one of my lectures, Professor G. Venkat Subbiah was there. I was telling the sixth planet from the sun, Saturn, is called as Shani. I made a comment, I don't know why, that has become an abusive term now. Shani is the word. Okay, I don't know why that name was given. After the lecture, he came to me and said, in Kannada, he told, Nodappa, ಯಾಕೆ ಅದಕ್ಕೆ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ ಶನೈಶ್ಚರಹ ಅಂದ್ರೆ the one who moves slowly. That is correct. Mercury was relatively moving very fast when our ancients saw. That is why Mercury is named after the messenger god. Messengers go very fast, you know. So Venus is different, Mars is different, Jupiter is different. Saturn was moving relatively slowly compared to all others. That is why it was called as Shanaishcharaha in Sanskrit. Thank you. Thank you very much.
Thank you. As I promised, we have the visit to the gallery. You want to see the Bharat Ratna medal now? Okay, we'll go and visit and we'll make two batches. One batch will go to the Chemical Heritage Exposition and another batch will move to the gallery. Okay, I'll be coming with you. Myself and Prabhu. Prabhu sir will take care of that Chemical Heritage Exposition visit. And before that, can we take one group photo? Yeah, you just go there and there is a stairs, Okay, go and have a seat. Okay, staircase. I request Rohit and Ramchandra Bhatt to, guide us to get the photo. Yeah. Ramchandra Bhatt and, Rohit, our previous awardees. And there is a B.S. Shashikumar and he is also our awardee. Okay, fine. Just go and have a seat there in the stairs. Up. Quick, we don't have time. You have 2 minutes.
AS and okay. So you will take care of this. How much solution you're making like this? KO3 is 20 ml. So you make it substitute as 20 ml. Okay. These two, right? H2O also 20 ml. So total 40, right? Total 40, and then use this beaker. Okay. Good afternoon. Is it working or no? Hello? Not working, looks like. 1 hour something there, right? 1 hour, right? 45 minutes. Whatever.
Whatever.
No, no. You have to go there, no? Okay.
Okay.
So,
One more thing. Yeah. 3 to 4.
3.
yeah, works in
Yeah,
phases.
and I forgot to tell you, Professor C.N.R. Rao's, favorite postdoc, Dr. Pratap Vishnoi, he has done a lot of work with Professor C.N.R. Rao, that is especially 2D and 3D nanomaterials. The molybdenum sulfide, it is analogous to graphene. And recently, for his work, he has initiated those work, they got the patent. And, these are all remarkable work, which is carried out by our Pratap Vishnoi. In future, you people will be using, after 10 or 15 years, the applications of, Pratap Vishnoi's. Yeah, thank you.
So thank you very much, Dr. Vinayak. Am I audible up to the last row? Okay, great. So good afternoon and great to see you all here. This was a very exciting day today. So we have set here a small chemistry laboratory, or we have friendly chemicals here. So what we try to do is, the science is all about experiments, right? Whether it's chemistry or physics or any other field, more experiment you do, more you learn. So here we are trying to learn few experiments and the chemistry behind that. So I'll be not going through all these, the very basics of one of the experiments that I'm sure many of you, if not all, are familiar with. Are you familiar with this kind of experiments or perhaps heard about it? The starch iodine complex, right? It gives immediately color, and many of you might have, seen in laboratory or so. Moment you had starch in iodide solution, particularly should be in this form, I3 minus, which is a linear molecule. Those from chemistry will perhaps understand more about the structures. So what is the structure of I3 minus? Yeah, feel free to raise hand. Even your answer is wrong, don't worry about it. What is the structure of I3 minus? It is like carbon dioxide, linear molecule is shown here in this one. You see the 3 iodine are there. Okay, it's a 3 iodine form a chain with this one, a very small chain. So this is a starch here. You have 2 components in a starch, amylose and amylopectin. The complex molecule or the biomolecule, which is found in several of the stuffs that we eat. The wheat, the slice, the potato, and corn, and so on. So now here, what we want to understand is one of the experiment how you detect iodide and how you correlate the starch and iodide complex using this complex, the iodide concentration. Okay, here I have one reaction. I'll come to that, but let me start the experiment. So the chemical that I have here in the table on the table is potassium iodide, sulfuric acid. I have sodium dithionite, and then I have starch and water. Okay, I'll come back to this, but let me mix them in some way as written in the table, and then we'll see how this color appears. And I'm going to call this as a iodine cloak reaction. You can make a cloak out of this experiment. So let's try that. So what I'm going to do with me, Vishwajit, my PhD student, is there. He will be helping in the experiment, and also Partha, who's somewhere in the audience, he will come back. Okay, so let's start adding the. So we have a stock solution we will make here of potassium iodide. It's here already. So here in the volumetric flask, which is 250 milliliter, I have potassium iodide solution, the very first one there. And this one I have as a sulfuric acid. And this one is sodium dithionide. So they will react. So in the precursor, what I have is this one. If I go back and show you. In precursor, I don't have I2. What I have is I minus. Ki is potassium plus and iodide minus, I minus. So I'm first reaction, which is of course a slow reaction. When reaction is slow, remember that is also a rate determining step, right? If you talk about chemical kinetics, if your reaction has two steps, the fastest one will finish fast. It cannot determine the rate of the reaction. So the slow reaction will determine the rate of reaction, meaning the chemical kinetics, how fast whole process will finish. The first one is important one. Okay, so let's make the I2 minus. There's a diiodide common molecule. Yeah, can we add this? Yeah. So we'll add chemical in this sequence. Sulfuric acid, then starch, then sodium dithionate. At the end, the last one we are going to keep hydrogen peroxide. That will be the last reagent. Okay. Yeah. So this is Ki. Okay. And which is the bigger one? That side, right? Yeah. Okay. Let me add water. I can add it. I need one more. This one. No problem. I can use. So I'll add in the meantime sulfuric acid. We have extra beaker. Is it extra? Oh. Have you seen sulfuric acid in laboratory? What is the physical state of sulfuric acid? Liquid. What is the concentration? Please say it loudly. Concentration. Is it pure or solution you get? Okay, so I added sulfuric acid. Sulfuric physical state is liquid, right? Is that correct? So you get in pure form 98 or 99% something. So you cannot call that as a solution because it's not a mix of two things. It's a pure. Okay. So from there we made a dilute solution. Mix water in that. Okay. Now we are adding water, the third component. Here in a different concentration. You see different amount. At the end of this addition, we want every beaker to have 200 milliliter because the total solution we want to keep constant because we want to check when you add different amount of iodine, how the color appears at different time interval. Okay, and I'll show you how chemical kinetics of that works. So what is the next one is starch. Let me add the starch. I have starch here. Is the starch soluble in water? Why it's so? That's correct. Very nice. Why it is so? Density. No, starch is solid, so you pretty much don't worry about density. Why something is soluble? Let's say sodium chloride, you put in water, it becomes soluble. Why? Exactly. Okay, the big molecule non-polar. So how do you make it soluble in water? How do you make it? Yeah. By heating. Okay, that's what we did some time ago. Okay, so now we added a starch, we have added sulfuric acid, we have added water and Ki. We have left with potassium dithionate and hydrogen peroxide. Can you rinse this? Right now, use this. Enough, give. So I'm adding 10 milliliter of sodium dithionite solution, Na2S2O3. It's called sodium dithionite. Dithionite. Can you give me pen? Which is one in this? The least concentration. That will be faster. This side, right? The only thing is now the hydrogen peroxide, right? Is left, right? That's all is left, no? This thing you can transfer. Maybe you have to rinse it once. Okay, then put it there. Do we have this enough? So I need 5 volunteers. Maybe a mix of boys and girls. You have this enough. Huh? You want girls or boys? Either. No, I want both. Huh? Fine. Okay, you can come this side. Okay, so the beaker on the left, your right side, is the first one, where we added minimum amount of Ki. That one is the last column. Okay, the others are in between according to that table. So it's basically matched with the arrangement of the column. Now what you are going to do is we are adding 2 milliliter of hydrogen peroxide in each of these beakers. Now the precaution is you all have to add at same time, one, and do not allow this drop to fall somewhere because this is corrosive. Okay. So what you need to, I'll give you all 2 milliliter. It's basically labeled a dropper. Okay, so can I have the tissue is there, or any paper piece is fine. Huh? And that's enough. That much is enough. One or two pieces enough. That much is enough. So you, 1 minute, you hold it like this. When I say you have to pour it, you just have to do like this. Okay, meaning this opening should not be outside of beaker. That's it's easy. Otherwise, no problem. Just hold it like until that. 1 minute. Huh?
I said 3, 2, 1.
Keep holding like that. Okay. Yeah, please go ahead. Is it thionite? There's a mistake there. Okay. Oh, Na2 S2O3. Yeah, there's a correction there. I'll tell that. Huh? Very nice. Thank you. Yeah, thionite. I'll tell that. Okay. Others may already be having something. So as I mentioned, starches, and many of you told starch is not soluble in water. You see, they are already becoming hazy. You see haze appearing, right? Okay, well, you can come this side. Where the okay? So after that, once you have to completely vacate this, drop everything inside carefully, and then use this to stir it. Okay, like this. Yeah, same thing like this. Once you do this, like this, and I'll tell you when to stop that. Huh? Drop it, but there's no hurry. I'm aram.
That's it.
Yeah, just press it and yeah. Okay, so 1 minute, 1 minute. That should be in the
time ಆಗ್ಬೇಕು ಎಲ್ಲರೂ ಹೆಂಗ್ ಆಗ್ತೀರಾ ಮಾಡ್ಬಿಟ್ಟು ಪ್ರೆಸ್ ಮಾಡ್ಬೇಕು ಸುಮ್ಮನೆ ಹಿಂಗ್ ಮಾಡೋದಲ್ಲ ಗಾಟ್ ಟು ಪ್ರೆಸ್.
What is that? Okay, now yours is this one. Okay, first one is his. Is yours and is in same order. You come. So he will tell the timing. Yeah.
Okay, guys, keep quiet. 3, 2, 1, go.
Full vacate, full, and then do it. Now it's fine. Once you're done, stir it, stir it, stir it.
Take it out. ನೀನು ವಾಪಸ್ ತಗೊಂತಾ ಇದೀಯಾ?
Okay, so what do you think? Which one will give color first by reacting with the starch? First one, is it? Oh wow! So it took about 30 seconds. Can somebody note down? 30 seconds. You can just note down. It's fine. 30 seconds and then keep noting down. Yeah, this is 50. I'll tell you when third one appears. Okay. So why do you see this is hazy? Others, there's a haze, right? It's not transparent, right? What happened? Because as I mentioned, starch is not water soluble. We dissolved it by heating forcefully, but now they are at room temperature. So the starches kind of try to precipitate. Okay. Is it appearing? Oh, I see. It's like clouds is appearing. Okay, so this is 1 minute 55 seconds. So I'll tell you while it is going on, in all these. Oh, happy. Okay, so you 2 minutes 25 seconds. So I always tell when I do this activity, you can make a mix of chemical in such a way that the color might appear tomorrow or a month later. You can do that time, you can calculate and you can say, so that's why we are calling this as a clock, because you can make a timer out of this. Okay. So why color is appearing at a different time? Because for color we need I3 minus. Starch is constant in all the beakers, so that is not the key. Key is in how fast we are producing I3 minus. Once it is a little access, meaning it is available, it goes in the starch chain and it gives color. Why does it give color, by the way? Anybody? Why starch and the iodide complex gives color? Yeah. So what bound doesn't mean color. Very good, but you have to have additional thing to give color. Yeah, go ahead. No, let the answer be. The worst what will happen, it will be wrong, not worry. What? Yeah, please say it again. So what happens is there is electron transfer from a triiodide to starch because they are in very close contact as she mentioned. So now electron can transfer from one to other entity. There are two partners. Because, can you please keep quiet? Because there is electron transfer needs energy. And energy that it consumes has a wavelength which is equal to this blue. It's actually dark blue color. It's not, it look black because it's so dark, so intense. So it look black, but it's blue actually. Okay. So the energy that electron transfer needs from the visible spectrum correspond to this color. Okay, it's still not appearing. So it will take time.
Yeah. We'll move to the next experiment.
Okay, let me take time, no problem. Now, let me tell you something very, very important about why we are studying this. Are you aware of chemical kinetics? I believe some of you are there. That's a great thing. But as you keep going forward in your classes, you will see chemical kinetics. Chemical kinetics is nothing but when you see a chemical process happening. This is one of the chemical processes, right? In nature, there are so many chemical processes that are happening every day. Can you name a few which chemical processes are happening around us? Chemical reactions or chemical respiration, photosynthesis. There are so many things happening. One of the very good example is in the iron rod you keep in outside in humid atmosphere. It gets rusted, right? That's a chemical reaction. Iron reacting with water and oxygen, forming iron oxide. That's a rust. So how fast this reaction happens? How much time it takes? Study of this branch of chemistry is called chemical kinetics, right? Here also what we are studying, how fast this complex appears. Now, when you talk about how fast it appears, we are talking about rate of the reaction. Now, based on rate of the reaction, we typically call zero order, first order, second order. These are the orders of different reactions. Okay, I will not go into the details of what these orders mean, but zero order means the rate of the reaction does not depend on concentration of the precursor. So is this reaction a zero order reaction? The first reaction is the rate determining step, and we are controlling Ki, and the rate of the reaction depending on our control. That means it's not a zero order reaction, right? Now it could be first or second order. Now the time that you wrote there, if you plot the timing on y-axis, you have to keep this concentration. Let me tell you this concentration. I have written in the bracket there, in parenthesis here. This is the concentration. You put these values on y-axis. You can try drawing that. Can you make a distinct plot? Just write a vertical line and put marks 0.0025. Then okay. Oh, is it just now appear? Okay. Can you write? It's a 7 minutes and 10 seconds. Or let's say 20 seconds, slightly this thing. I looked at it a little later. Okay. Now, yeah. Thank you very much.
Thank you very much. Big round of applause for our volunteers.
So nicely.
Yeah. One more time, claps.
What happened?
Claps are.
Yeah. Okay. Now I'll tell you what you are going to do. So you are putting this concentration on y-axis. Please, can you keep what the concentration on y-axis and timing? He has written timing. So if you want to know that, you can note down this. So here you are going to put concentration, and on x-axis you are going to put timing in seconds. Your plot will look like this. Okay. If it looks like this is nothing but, you know, y equal to mx plot. When you do this, you'll get this kind of plot. So this is a characteristic of first order chemical kinetics. What does it mean? Your rate of reaction directly depending on concentration of the precursor. And when you say rate of reaction directly depending on this means I'm putting concentration to power 1. When I say it is not a second order reaction, but this is a first order. But if I say second order reaction, you are going to say rate of the reaction is directly proportional to the precursor concentration to the power 2. Okay, that means you are going to give here timing square or something. Okay, so I think this is clear. If you can ask, can you stop at any time in between? So if you have a question. Okay, let's move on to another one, which is a very related experiment. Yeah, can we make this solution for globe? Yeah. Okay, some of the reaction. One of you had a question about error here. Is that this one correct? Na2S2, yes, Na2S2O3, sodium dicyanide. So there's error here. It should be 2. Okay. Now I'm using slightly different reagents. It's going to take time, then I can move on to this one. Yeah. Yeah. Do you have mix, no? Already. Yeah. Yeah.
One of them is this.
Okay. No, I don't need that. Okay. Is it 150 milliliter?
Maybe I can add some.
How much it is?
Yeah.
Do you have? Can you give me that beaker? It's clean, right? Okay, let's look at some, well, this we are doing this chemical mixing. Let's take a look at some color experiments. Okay. So I have a methylene blue dye here. You know what is dye? Dye molecule? Colored compound, right? Many of this cloth and color that you see comes from dye molecule. That's how dye industries, there are a lot of chemicals they add to waste, to the water drainage system and so on. Okay, so this particular dye, methylene blue, when the name itself indicates it's blue in color. When you add, it is water soluble. When you do that, it will look blue. So now let's do an experiment. We'll try to reduce this dye. So this is the dye formula. Those in chemistry will of course understand this, but others also I try to simplify this. The carbon and nitrogen, sulfur and methyl groups on in this way they are connected to each other. Now this look blue because these three aromatic rings are in conjugation. Are you aware of conjugation? Pi electron conjugation. What happens when you increase pi electron conjugation over a larger system? Will there be a shift in spectrum? There will be a shift in color, right? There will be. There will be shift in intensity. You see hypsochromic, methochromic, those kind of things you will see. So here, because it is a conjugated, is color. Now, if I reduce this, the first site that get reduced is nitrogen. That is most susceptible to reduction. So once you have this form, you see these two rings are separated. There is no pi conjugation anymore. We can do this reversibly. How? The reduction here is the addition of proton. It's a very simple process. You say the proton addition, and we can use gluconic acid, which is the organic acid again, to do this. So let me make first gluconic acid from glucose. So what I had in this bottle, I took earlier the dextrose, is called dextrose or D-glucose. Okay, and I mix what? Water and KOH, potassium hydroxide and water. That is already there in this bottle. So there are three, but we don't know whether anything happened or not because the aqueous solution of glucose is colorless. And even it doesn't tell whether anything is dissolved or not. It looks like water, right? Plain water. So we don't know. But since I mixed, I know it is formed. But you will also know in a moment that gluconic acid in fact formed. Okay. Now, how do you know? If there is a gluconic acid, then only the reduction will happen. Otherwise, it will not happen. So I have here the commercially available methylene blue. And I'm adding a drop or two of this one. The moment you edit, this is blue. Okay, let's see what happens. As I said, That has to be blue. Nothing. We have not done anything because natural color. As I said, if reduction happens, the color should disappear. Why? Because conjugation has gone and compound starts not to absorb in any part of the visible spectrum. What is the wavelength of visible spectrum? 400 to say 1750. No, that's the range. So this, okay. By the way, where does this absorb? What wavelength this compound is absorbing? So 400 is around 450, the wavelength, the color that you see. Why? Why you said so? What is the wavelength of blue color? Blue one. BBQ, that's where you start, no? 450 around that, right? Now, what color it has absorbed? Oh my God. In the meantime, this has lost its color. So what had happened is this one. I'll come back to color. The top reaction has happened. Okay. And it's reduced to a colorless compound that's called leucomethylene blue. Now I have written the arrows, which is also one of them is, going backward. What does it mean? It's a reversible reaction. That means this reaction you can reverse, right? Let me try to reverse this without putting anything extra as a chemical. It has appeared back. Now, I try to do this reaction, the arrow below, the backward reaction. Top one is called forward reaction, backward reaction. How did it happen by stacking this? Huh? No, but I will only shook it, right? I didn't pump oxygen or anything, it's closed. See, atmospheric oxygen is many times it doesn't react that fast. Okay, so if you shake it, you are basically providing mechanical force. Okay, what mechanical force does for any reaction in general, the reactants or you call reagents, I think these molecules should collide with each other, right? They will collide and they form transition state, then goes to product. So what I'm doing by shaking is I'm making their collision fast. Okay, so I'm basically this molecule and its collision with oxygen molecules I'm making faster. So I'm kind of catalyzing the backward reaction. And forward reaction doesn't need any shaking because it's a reduction. There's plenty of gluconic acid is there, which gives, this guy gives proton. Where is the active proton in this? There. This is acetic acid group, COOH. The one of the functional group, right? Which has active proton. That proton can be taken up if somebody wants. Here, this guy needs nitrogen. Why? Why this nitrogen is more kind of eager to be reduced? Can anybody want to try? Lone pair electron, okay? Lone pair of electrons are here, which can bind with proton and it's get reduced. Okay, so this you can do back and forth multiple cycles, I think. Now let's move on to one more, next level of this one. Let's do this. I need more water in this. Another 50 milliliter. Oh, here is an important aspect, very, very important. Let me tell you this. This methylene blue sometimes is used in medicine. It's very simple concept is this. Methylene blue I just mentioned, using acid you can reduce this, right? So in our body, we have acid called NADPH. If you read biology, you will get about this thing. It has a proton, which is the active proton. Okay. So if methylene blue is injected in body, it can get reduced by NADPH. This compound is there in our body. So it will get reduced. But then when you want it to reverse, outside I did with oxygen, but in body you can use hemoglobin. Okay. So to oxidize this, the iron 3 will come to iron 2 plus. Now what is use of this thing? We have hemoglobin. What is the oxidation state of iron in hemoglobin? 2 plus. But in certain patients, it for some reason become 3 plus, and that hemoglobin cannot carry oxygen. So you use NADPH, the methylene blue, which will in oxidation state, it will come here. At the same time, this meth hemoglobin, that is a problematic thing, will come back to the regular hemoglobin. So this is where methylene blue is used for treating the patient. And it is methylene blue is found to be no toxic effect. Okay, let's do one more experiment. So again, in this bottle, I have, can you please keep quiet? Again, I have acid here. Is a gluconic acid. You cannot make out whether it is there or not because it doesn't have a color. Okay, so color is a very good indicator about whether something has happened or not. So I'm adding another dye called indigo carmine, which is color is, the name suggests what should be the color? Indigo, okay, which is close to blue. So I have solid indigo carmine. Earlier one was a solution. This is solid. A very little pinch of it I'm adding. It's actually blue, but in this gluconic acid solution, which is already there, it turning into what color? Green. Okay. It is not very obvious. It will become obvious now. So you see, this is green. It was originally blue. In this bottle, it is blue. Okay, now let's see what happens to this. Oh, yes. What is the color now? Red, right? Okay, so again, my question is, so which color it absorbed? So it look red. It surely didn't absorb red color, right? How did you find out green? There's something called opposite color. Okay, I'll come back to this. So now what is the color? It's almost yellow, turning yellow, light orange, and now it's becoming yellow. So now at this stage, you see this formula here. Now, if I don't do anything, it will remain like this forever. But I can do this. Not too much collision with oxygen, a little. So you will see this. But if you are too much into color business, so this will happen. Okay, so okay, let me explain the process. You remember how many sites were there in the previous dye molecule which are ready to be reduced? How many were there? Previous dye. Only one. So since it has one, so it will be either colored or colorless, because there is only one point where you can make change. This has two. This time not nitrogen, because it's already proton is there. So it's not very useful. But this site is there. It's called ketonic site. Now how many are there? Two. Because this is symmetric molecule. You can put a plane here, right? Can cut into two half. So you use this and next time use this, you'll see 2 time color changing. Once here, second time here. So the first reduction took place, let's say one of these sites. I'm here I've drawn this one. So you see the ketone can change to alcohol. And then in the next part, the another site where this has changed to alcohol. So what you saw yellow now, it is this compound. But if I slightly, not too much, I will do this reaction. To do this reaction, you have to slowly do peacefully. Now I am here. And if I allow it to be stay there, this will happen. It never will go there. Okay, now slowly you'll see it become yellow. I'll show you and then I'll move back. You see the yellow is already, kind of. You see, right? Turning yellow. Now let me do this. So I am here. Now I am here. Now I am here. Okay. Now you leave, don't do anything. You will be here, then we'll go there. Okay. So this dye is also available in market. You can do that. All these are very familiar, the friendly chemicals, no problem. Huh? Another 10-15 minutes there? 10? Okay. Let's try one experiment, which is again color based. I come back to iodine. So let me finish about color chart. Why something look black? Why? Black SS is not a color, right? But why something look black? See, dark night, completely dark, nothing you can see, right? Because there's no light, right? When you say no light means I'm saying there's no color, right? No, none of the 7 colors available. So you see black. So what black means, any surface or anything is black means it has absorbed all visible light. So when light falls on a subject, an object, if it absorbs everything, what you see is nothing, is black. Now, if a light falls on object, here we have chemicals, it will absorb some part and leave something, the remaining. The remaining that reaches to our eyes, how many colors are there? Meaning out of 7, how many colors this has absorbed and how many left behind? Let's say it absorbed 1. We have combination of 6 color left that is reaching to our eyes, right? So if this looks reddish, that means it has absorbed green. Out of 7 green color you subtract, 6 colors are reaching to my eye, so I'm seeing this is red. Okay, now what I did, it looks green because it's absorbed red. So out of 7 you remove red, remaining 7 will look green. That's a chart, you can see that. Okay, so it's a very interesting. If 7 colors are available to you, thing will look white. If 6 are available, depending on what is subtracted, you will see the remaining as one color. And likewise, you can play around the color thing. Several colors can be produced out of the 7 colors, primarily 3 colors. Okay, so yeah, understood. So let's have a rotation. It will bump, right? Yeah, that's enough. That's fine. Okay, so this beaker has a. I'm coming back to iodine experiment. It has hydrogen peroxide, right? So what Vishwajit is adding is potassium iodate in this supposed to hydrogen peroxide, right? 5H2O2. So now what is that you added? What you're adding now is starch. Okay. Or to catalyze that. Okay. Yeah. So let's see what happens here. Yeah, can you please keep quiet? So you see this color fluctuate. It goes on several cycles. You can make a big column like this and put a stirrer. So this is related to this reaction. Here intensity is not that high. You see it's blue and colorless. In the meantime, it's becoming light yellow, which you don't see at this moment. It's going through now. See light yellow, blue, and then colorless. So what is happening is, let me tell you the chemistry part of this. When it is yellowish, you have first reaction completed. You have plenty of iodide in this I2, whose color is like this. Once you have second reaction done in a sufficient amount, you have I minus, which combined with I2 forms I3 minus. There's a minus here. And moment I3 minus is formed, even in a little quantity, there's a plenty of starch around. It will form a complex with a starch that gives color. Okay, so we'll stop it here. Yeah. So big round of applause to Vishwajit and Partha that do this experiment very, very beautifully. Yeah.
Okay. Thank you very much, Dr. Pratap. And have you enjoyed this demonstration? Did you like it? Okay, fine. And with this, thank you very much. My special thanks to Vishwajit and Partha for preparing all the chemicals and everything and guiding them, by Dr. Pratap Vishnoi. And thank you. Please continue. So on behalf of C.N.R Hall of Science and Education Technology Unit, JNCASR, and from C.N.R Education Foundation, this is a small gratitude to Dr. Pratap Vishnoi. Okay.
Okay, so I'll make a move.
Please. Okay, guys. We'll keep it later. You can. Now, ನೀವೆಲ್ಲ ತುಂಬಾ ಗಲಾಟೆ ಮಾಡ್ತಾ ಇದ್ರಿ. I told you if you break the rule number 2, and I'll take you for the coffee. ನಿಜನಾ? ಸುಳ್ಳು ಹೇಳಲ್ಲ ನಾನು. Okay, now we will have a coffee because ನೀವೆಲ್ಲ ಗಲಾಟೆ ಮಾಡಿದ್ದೀರಾ. So before that, I'll show a small trailer. That video, the physics video. One video ಇದೆ ನೋಡಿ. And out of all those experiments, I'll do only one experiment. That is a physics experiment. You want to see the magnetic levitation train? I have a train, superconductor. Okay, with a liquid nitrogen. Okay.